gallons a minute you would want. But if you can get, I'm trying to think of the specs on the last one I just did and how many gallons a minute we were putting in. It slipped my mind at the moment, but you can have that water moving through the system pretty readily, and you can rely on your overflow, very little, and you can handle a pretty heavy storm before you have like the whole thing just kind of floods itself out. I probably didn't answer your question, but I'm not sure like when you're looking at, I guess I'm not sure like what you're, I need a little bit more context, I guess.
Hey, Trevor,
I was just curious.
Go ahead, Randy, finish.
This is Dave.
Dave, go ahead.
In Florida, we had this problem because there is no outfall. If your perk pond did not dissipate the water, it would overflow onto the streets or wherever you were at. You have to use, when you upscale the design so much that you're putting in a pond that's 40,000 or 100,000 square feet, it's no longer applicable to use a percolation rate from a septic system that was based on empirical design methods for small little areas, because you're making the water flow 200 feet laterally to get rid of that water. Whereas in a small perk test situation in a home septic system, it's only flowing 10 feet out away from the bed. So you have to use a much more complicated analysis, and that's what I was cautioning. It's great for these little rain gardens, the perk test. It's a quick method to analyze, but you can't upscale it to an acre pond and expect it to work.
No, definitely not. But I was thinking, I was taking Randy's question as, if I have a right of way or if I have a parking lot situation, and I'm creating a bioswale to handle that runoff, what size rain event am I looking at, and what type infiltration do I need, and sizing that rain event. Normally when I'm sizing kind of like per inches to figure out how many, like if we got 3 inches, in an hour, what's that going to look like, and can this handle it? Because that's feasible. 3 inches or so in an hour is possible. That could happen. So in looking at that, that's how I'm usually looking at and sizing. I'm like saying, okay, how many gallons is coming off of this, say, parking lot? And if we get 3 inches in an hour, how many gallons is that going to be? And that usually determines, in like step one, how big my system's going to be when I'm looking at it. I'm trying to size that system like if it were a bathtub, and then I start figuring in like perk rates and everything else to kind of look at how long can this thing handle before it starts going down the overflow, or before the whole system itself is just overwhelmed. And I've definitely undersized systems before. I mean, I'm not even gonna lie. I've definitely undersized, smaller systems, and then we get like that 2 inches in an hour, and that thing really was like a bathtub, and it was just flowing down that overflow like crazy. And that's just, when you get overwhelmed like that, it's crazy. It's just terrible. So, since then, I've just done everything I can to almost over-engineer. So that's, so it takes a hell of a storm. And if it really does fail, I don't feel so bad, because it is like that 100-year storm that, that's going to kill it. So Randy, I don't know that I even kind of answered your question, because like I said, I need a little more context. I also think and approach these things, I realize this from talking to you already, all of you, that I approach these things a little bit differently than all of you do. So it may, for me to kind of back into your thinking may take a little bit. So so that's why I need a little more context.
No, I think you answered. My question was more, is there a standard you try to hit? Is there say a 10-year event you try to meet? it sounds like you're basically sizing it as big as you can and hoping you get as much runoff to infiltrate into the ground, each rain event. So that's fine. I understand your response.
Okay. Well, I appreciate the question, but yeah, I mean, I understand by you thinking like that, like I said, I don't go right into thinking 10-year, 100-year storm when I'm looking at it. Like I think of it more in gallons and rain, like a singular rain event. And I know that like when you guys are designing, you're thinking like, okay, can this handle a 100-year storm? So like I said, that's something I have to sit with and back into a little bit more than just, it's easier for me, just the way I've kind of trained, just to look at it and calculate water, calculate worst case scenario and say, can I handle it? And then from there, it's obviously no. So then I kind of have to back into, okay, can I handle second worst case scenario? And then that usually depends on, say, like size, how big can I really get? And then I go down to, can I handle, say, third worst case scenario? And if I can get into that, then I can handle almost any rain event that's coming our way. Because the majority of our rain events are 1-2 inches. And I can easily, anything that I'm designing can usually easily handle 1-2 inches, except for like, maybe not a rain garden. Rain gardens I designed for a 2-inch rain event. So if we ever got anything crazy, that's just a rain garden. I'm using native soils and everything else. So if we ever got like a major mega rain event, or if there was a whole lot of surface runoff, then yes, most rain gardens that I'm designing for that'll end up absolutely going down the overflow. But when you have the ability to kind of formulate your percolation rate, and when you can put in an underdrain, when you have those backups, when you have an underdrain, when you have an overflow, because if that water is moving through the soil and then doesn't have to stay in the soil, if it's going to an underdrain, then you're moving that water out of there. If you have a bioswale and that water is moving through the soil and then hitting native soils, well, then it's going to drain a little slower. So you're still able to perk it, but once it hit native soils, it might slow down. So it's all kind of depending. And like I said, I over engineer, and I love to give myself plenty of backups, because in all reality, I don't know, we in the next month, we could get, 400 or 500 year storms, in the month. Who knows the way things are running right now. So I like to back up my backups, and make sure that I have proper flows and everything else, because I really need these things to be successful. Otherwise, nobody's going to listen to me anymore when I come and try to talk about them. So that's really, I kind of come at it, I don't want to say I come at it shook or scared, but I definitely come at it cautious and prepare for the worst. And more often than not, especially recently, I end up, looking pretty good in the rain events that we've had. So anybody else have any questions?
Realistically, what kind of how small can these be? And I'm thinking more right of ways. Like how narrow can they be? I know it depends on how much length you have to get the volume, but in right of ways, like how narrow have you gone? Like on roadways.
If you're on a roadway right away?
Yep.
Eventually, if you go too narrow, eventually you have a gully or a trench.
Exactly. So what? Exactly. So what?
You want to be, at least, I'd say at least 10 feet to 20 feet wide up top.
Okay.
And especially from the conversations, that have been kind of floating around on here in our first couple of days. It really is like you want the center of your swale to be a good distance from the edge of that road, because you do not want to be super saturating, the edge of the roadway, because that's bound, especially for autumnal storm events. You're bound to get freezing and heaving and everything else. And then if you do super saturated soils in the springtime, like now, and then you drop down to like 15 degrees at night, those roadways are going to be gone. So you want to make sure that that water is well enough away and moving at a pretty good rate. But yeah, you can't, like, having a 5 foot, a 5 foot at top and say a foot at the bottom, that's pretty much a gully. And you're gonna almost channel the water too much, where it'll pick up too much speed in that tight of space. It won't be able to spread out and slow down, which is what we needed it to do. If it's too pitched, it's just gonna move at a pretty good clip. Thinking about maintenance as well, in doing all this. And the maintenance part is, I actually got quite a compliment after our class yesterday from somebody who works with the MVP grants and everything, saying that after our conversation, she saw me present, and after our conversation, she was like, I just drive home maintenance now at every turn, and everybody that I talk to, because it really is. It's setting up maintenance from the beginning. It's like, okay, I want this, I want this bioswale on this right of way. You have to calculate how much water it's going to take and everything else. But, if the sides are too steep or whichever, then can anybody really get in there and mow it and maintain it and make sure that it's functioning? Or if you're not going to mow it, if you're going to plant it up, are you able to get in there and keep it open? And is it open enough so that it'll dry? Because if you have like a real tight, swale, then it's really just going to constantly be soaked at the bottom. And if it's constantly soaked at the bottom, then you'll get these anaerobic conditions, which are going to kill the soil, which will then eventually kill the plants. And you won't be able to really infiltrate any water if you're constantly wet. That thing does need to dry out to a point. You don't want it super dry, like total dust dry, but it needs to dry down so that it can absorb again. Because what happens when our soils get too dry, if we bake them and they get too dry, they become hydrophobic. So then we get a rain event, and then it may as well just be running along concrete. If you have a super dry soil, then you've lost that that surface tension for it to absorb. So you have too much surface tension, so you have to break that so it can absorb. So we have to kind of find that perfect balance. We want to stay at like a 4, on say the moisture level at our driest point, so that when we have a rain event, it's ready to absorb water again. Because if we get down into that 2 and 3, where it gets super dry, then it's going to get hard and start to become hydrophobic. So I think, it's in designing and in thinking about these, you need to calculate, as Randy was saying, as we were talking about, you need to calculate the storm, you need to calculate the water, but in part of doing that is making it practical and easy to work on and work with. And that'll also kind of dictate the design and help guide you to say that perfect shape or the type of system you're going to choose, etc. So, but yeah, eventually you become a gully, and if you become a gully, then you're speeding up your water, so that won't work. Anybody else?
So I just want to mention while everyone's in the room is that we are recording these sessions, and they will be posted. If you want to review anything, or if you miss a part, you can go and look at the videos, and I'll send that link out probably later today or tomorrow.
And you can always also email me any questions. Any questions you have that you don't want to ask here, any design specific questions. You're like, hey, I'm working on this. What do you think about, these are the ideas I'm considering. What do you think about this? I'll be more than happy to entertain any of those. Anything that takes a little bit of thought so that I can kind of consider. I'd be more than happy to kind of look at those and entertain those. As far as today goes, we are going to see, because we're cranking through the material. So what I think we'll do for today is we will hit up permeable pavements, but then I'd actually like to, if I may, I have a presentation tomorrow for Coast of Maine Botanic Garden on green infrastructure. It's designed a little more for the landscape professional, but I think I'd like to try it out on you guys just to, so you guys can be my guinea pigs. We'll just go through it. And like I said, it's designed a little more for the landscape professional. So the examples in it are more residential. But since we're flying through all this and we can't necessarily end a couple days early, we'll make today a real easy day. We'll go through just the permeable pavement part of this. Then, like I said, I will go through that presentation that I just finished this morning for tomorrow's presentation. I'll be able to see how that goes. And then wherever that lands, I think we'll just kind of stop there. So we'll just, today may or may not be a relatively short day, depending on how fast we move through this stuff. But this is all the stuff. Bioswales and permeable pavements are, aside from, well, I guess what we're coming into is what I have the most experience with. Bioswales, permeable pavements, rain harvesting systems, and of course, like dry wells and stuff like that, which we'll get into. Green roofs. You know, these are all things that I definitely have experience with, can answer questions on. I would be surprised if many of you are considering green roofs, but you know, I'm more than happy to talk about green roofs. You will need to know it for the test.
Hey, Trevor,
Yes.
is Coast of Maine paying you in soil amendments?
No.
That's too bad.
Yes.
Good stuff.
No, so it's, yes, definitely good stuff. But so yeah, so it's definitely a fun presentation. Like I said, I just capped it off because I started overthinking it. I've been thinking in this realm so much, so to try to like step it down a little bit was kind of hard to try to get into like a little 101. But let me get into, before we get into 101, let me get into permeable pavements. So personally, I am a big fan of permeable pavements. The downfall that I find to permeable pavements is the follow through. It's well, as the example that I gave was finding people to put them in correctly, but as far as compared to a bioswale, it's relatively easy to install a permeable pavement stormwater solution properly. What happens here with these is the follow through and the maintenance. For instance, Arlington, when I was consulting on some of the stuff that they want to do in their downtown square, not to sell anybody out, but they're like, oh, we're going to do permeable tree pits. And I said, okay, well, what's your maintenance plan for the tree pits? And they're like, oh, we don't have one. Well, they were going to use Porous Pave. You may or may not have heard of it. It's a product that I install a lot of, which is an asphalt alternative made with the rubber chips. You may have heard of Flexi Pave. They're both kind of competing. So they didn't have a maintenance plan, you know, whatsoever. And if you don't have a maintenance plan for permeable pavement, it ends up just becoming impervious pavement, in which case their tree pits would just kill them. I just did a proposal for the city, I guess they're a city of Salem. They're doing one of their parks all over, and they have about 3,000 square feet of this porous pavement going in. And they too, when I asked, I said, hey, what's the idea on maintenance of this? Because it needs maintenance. It needs vacuuming. It also needs resurfacing. And that was not factored into any of it. So it's like, again, like what I see a lot of is wanting to get this stuff in, but not knowing what to do with it on the other end, and in which case it's going to fail. It's either going to be ugly or it'll die. So for these things to be successful, there needs to be the thought on the other end. And so for all of you who do the design on here, you know, that needs to be a part of it from the beginning. When we were talking about the O&M manuals and the like I said, I'm pretty detailed with these things, because I need them to be successful, because the more of these things that are successful, the more people will believe in green infrastructure, and also the better I look. So instead of just trying to crank out a design or crank out an installation, you know, it's going into it from the beginning, trying to make sure that it will succeed. So here we are. It's 7 of 13. Like I said, we're cranking through this stuff. And like I also said yesterday, the idea behind all of these next modules are really essentially, it's going to be, what is it? How is it installed? How do you know if it's functioning properly? And how can you maintain it? We've really been through the longest of all of them. So after this, all of these modules are relatively short. This is probably the next longest one, and after that, they're pretty brief. So we're going to describe the components and basic functionality of porous asphalt, describe the components and basic functionality of pervious concrete, permeable pavers, and plastic grid systems. Identify the signs that they are working properly. You're not seeing it?
We're not seeing the presentation. We're seeing the menu
Oh boy.
from your computer.
There you go. How's that?
Great.
All right,
Thank
perfect.
you.
All right. Sorry about that. So the general overview. Permeable pavements are similar to conventional pavement, as they provide structure and support for vehicle traffic and pedestrian traffic. They have the additional benefit of allowing water to infiltrate through them. They can receive runoff generated by nearby buildings and non-permeable paved areas. Other areas and surfaces should be stabilized before runoff, for runoff, so they don't flow on to the pervious surfaces. Something that happens often where in, say, parking lot situations, the mulch beds just flow right onto the permeable pavements. Traditional pavements are designed to support a variety of different size weights, vehicles, speeds, and weather conditions. They are impervious as they do not allow water to pass through them. Permeable pavements are also designed to support similar vehicle loads, but they allow water to pass through them. Pavement surface may be temporarily stored the aggregate base until infiltration occurs. So the whole idea behind porous or permeable pavements is it's all about the base. It's all in the base. It's all in the construction and the integrity of the base. And if you have that proper base, no matter what you put down, whether it be concrete, pavers, or asphalt, it will do just fine. You need to have that proper storage. You need to have that proper drainage. That starts with crushed, clean aggregate from the beginning. So you have the aggregate base, can range from a few inches to a few feet, depending on how much water you want to store. So what we will be talking about in here, and then we'll look at a little bit on the other end, is porous asphalt, pervious concrete, permeable pavers, and plastic grid systems. So for the asphalt, very much like regular asphalt, but it is missing the fines. So it is like regular asphalt, but it does not have the fines. So it's more aggregated, which is great because it allows the water to go through it. However, it does not have the strength and cannot take high-speed vehicle traffic. And there are certain weight restrictions for it. So it's, you know, it's great for general traffic. It's great for, you know, as far as installations are concerned, it's awesome for a parking lot. It's awesome for a parking lot. Here it says, you know, walking trails, that, you know, that as well. I think like all of these rail paths, bike paths, whatever that they're constructing everywhere now, I think pervious pavement should be a part of all of them. It just makes sense since most of them go through the woods, most of them cut very close to wetland areas, whether they be streams or vernal pools, etc. You know, so I think all of these bike trails and things that are being constructed should be done in permeable pavements. So this is, I mean, this is an ever-changing thing. I mean, this slideshow is already more than 5 years old. So technology has already come along a lot further, and hopefully we'll get there. But currently, the speed in which these things can take is limited, which is why it will never be a roadway at the moment. So the components of porous asphalt, you have the aggregate base at 1.5 inch or 2.5 inch stone, washed, crushed, or as they say, angular. So, but washed and crushed is the key here. Then there is a choker course. And then you have the pervious asphalt put over it. So for me, for some, and this is all like for the next two, for the porous asphalt and pervious concrete, hard for me to get, because for me to get either one of these things made for me, I need to have a significant square footage, because any place that I am contacting needs to make me a special batch, and to make the special batch, they need to clean all of their all the machines and everything to make sure that it doesn't have fines in it, and so it'll meet spec. So nobody's going to mess with me if I'm coming at them, you know, with like 1,500 square feet, 800 square feet. You know, you need to be coming at a parking lot size to make it worth anybody's while, or at least say like a basketball court size. At least that's when I've called and when I've looked into this, which is why porous asphalt I have the least amount of experience with, because finding asphalt companies that want to take this on, at least when I've called, or who make, you know, they'll say, sure, we'll do it. And then they give me, you know, an astronomical price, knowing that I'm going to back out of it and find an alternative.
Trevor, are you finding that maybe the plants aren't willing to, but if you can aggregate projects that want to make use of porous asphalt, is there anything like that going on, so that you have, you know, I remember South Hadley contacting me at one point asking about, you know, they had several residential properties where they wanted to do driveways, and, you know, I was in a position to aggregate it, and the plant didn't want to do it at that point. This is almost like 10 years ago now. But
Yep.
Are you seeing any of that?
I think if you could, I think that would work. I also have heard that there are companies more in the pervious concrete that are starting to either specialize in this or make this a part of their routine. You know, this and the concrete don't necessarily come my way, you know, too often. You know, as I mentioned, I am not the lowest bidder, so I'll bid this stuff, and then somebody else usually gets the job when it involves something like porous asphalt. But I think if you can, you know, if the demand goes up, or you could aggregate projects like you're saying, you know, then absolutely, because you're making it worth somebody's while to do it. But like I said, for me to call and be like, hey, I got a driveway, and they'll be like, what is it? I'll be like, oh, it's like 900 square feet. Well, it's not worth their while. And I totally get that. So, but things to know here is just things to pay attention as far as exam could be concerned, is that porous asphalt, you have the aggregate base, 2.5 to 1.5 inches. You have a choker course. So choker course here. And then you have the asphalt, which is standard asphalt minus the fines. So it's asphalt, choker course, aggregate base, and then the subgrade.
Trevor, I think I've heard that this has a longer life, but you were talking about maintenance. If it's so hard to get a hold of, like, how do you maintain these other, like, if you have, I don't want to say potholes, because I'm assuming, I don't know what they make, but like if you have to make repairs, how easy is it to get material for that? Or
for porous asphalt, I don't know.
okay.
You have fewer. What is great, what I like, and my main selling point for all permeable pavements in this area is that you have fewer or zero frost heaves, and winter maintenance, essentially, like you have less icing. So when you have like that freeze thaw in January, February, you know, where the snow melts down, there's no puddles, because once it melts, it just goes right through the pavement. So, and then it freezes, you know, when it freezes up, it's down in that storage layer. so there's nothing to worry about. So I find it a whole lot easier, and I find they last longer, but they do need to be maintained. As far as porous asphalt's concerned, I've never had to put a patch on it, so I don't know.
Okay, I was just wondering because, I mean, maintenance is big, but are there companies out there that do the vacuuming, like are in this area? Or,
Well, I don't know about your area.
Yeah, I can speak to that.
Okay.
Mickey Marcus, who owned New England Environmental, has probably the premier porous asphalt parking lot, and that's in Amherst. And he's spoken to us about that BMP and just sings its praises. He does have a vac truck come in, I think it's twice a year, in the spring and the fall. And he said it's pretty easy to maintain. There wasn't a lot of maintenance beyond that. And I think it had been there like 15 years already.
yeah, because I
But-
was wondering, just because I know that one of the main reasons that, you know, we usually don't consider porous pavements is because of the maintenance. You have to buy the vacuum.
Yeah.
So if you're gonna just put it in a small area, it's not worth it. If you're just gonna do it in like one area, one lot, like, is it worth it to buy an entire vac truck for that one, you know, municipal lot? It's not. So I was just wondering if there was like a renting ability, or, you know,
There is definitely
hiring
renting
someone
ability.
yearly.
That's what I do. I
or
rent.
hiring someone,
Yeah.
you know, to come.
I'm
in and
there.
do it.
I know there are people with vac trucks. I'm sure you could find somebody to do it. And like I said, for the most part, I either have or I will rent. So I don't have a vac truck, but I have for smaller jobs. I have equipment for that.
Great.
But yes, I mean, if you're for like an entire parking lot, if you're talking, you know, acres and acres, then you would definitely need that vac truck. What will make that worthwhile is if you plan more. So like that, where the vac truck comes in, as if there's either like a master plan or something for more than just an area. If you are just redoing the downtown courthouse parking lot and then nothing else, then it may not be worth it, because you're not going to want to get a vac truck just for that.
Exactly, but I don't see like any town just planning to do it all out like right away. I feel like they're gonna have a test case, which would be like a parking
Then the
lot,
other thing to do
bike lot, you know.
would be to bite the bullet and then rent your vac truck, so it pays for itself.
Exactly. So,
Hey Patty, that parking lot in Amherst, do you know how they treat that in the winter? Do they use straight salt or are they using sand?
No, you can't use sand on
Never
it.
sand.
And I think he was using very little of anything related to salt, because it was, you know, the water would just soak through. And so there wasn't ice sort of collecting on the surface. It would move through. But we can circle back to him as a group if you want to. I think his company got bought, but it's probably the longest, the porous parking lot with the longest life in our region. It might be good to check back in and see how it's doing, see if he wants to come talk to the Stormwater Committee. So we can do that, Randy.
Yeah, that'd be
So,
great.
As far as I've found, you never use sand. You can use salt. Salt shortens the life of all of these things. But with any, is in my experience, with just snow blowing, plowing, and shoveling, you are, for the most part, unless it's a heavily shaded area by buildings or whatever, for the most part, you never need anything additional. Because once you get it to there, once you get like that 10 o'clock sun or whatever, it pretty much clears itself up, almost like a heated driveway. That's just been in my experience. I know there are certain times when I've needed to put down, or I know that people have put down, usually like a salt alternative. But for the most part, not much of that has been needed, because the water, like again, like once it starts melting, once it starts capturing any of that sun's heat, the water just moves right through it. So there's less product needed on it. However, again, you do need to, and I always suggest a twice a year vacuum at least, spring to get all the winter salt that comes in off the tires out of it, and then fall to get out all that organic matter from all the crushed leaves, etc., so that it works properly over the winter. For porous concrete, you have the aggregate base, exactly like the asphalt, 1.5 inches, 2.5 down there. What I use is called the 257 stone. It's 3/4 and 1.5 inches mixed, which I absolutely love. Pervious concrete does not have a choker course. So porous asphalt does, pervious concrete does not. And then you pour that concrete over it. The concrete, you screed it out and spread it just like standard concrete. However, you do not push down. That is the big key with the pervious concrete, is that you don't push down with your screed or with your trowel, with your bowl float. You don't want to squeeze the pore space out of it. Pervious concrete also takes longer to cure, in part because you're missing those fines. So those aggregates are just kind of touching each other. So it takes longer to set up and cure. And you can see, if you haven't seen it before, you can see it looks kind of like a Rice Krispie treat when it's all said and done. So these are not glass smooth surfaces, either one of them, because they're so aggregated. So, you know, pervious concrete is concrete minus all of those fines.
Trevor, for any of these types, before you put on the subgrade, before you put that coarse aggregate on there, do you put something between the coarse aggregate and the subgrade? Is there some?
If you need, yes. So if you need to, I will put down. This is a case where, and we'll see it in pavements, but you're going to you don't want to ever compact. So once you excavate, you're going to excavate, but you're not going to necessarily compact the native soil. You don't want that hard and compacted. If your native soils are unstable or loose, I put down, that's when I use a geotex. I'll throw down geotextile or a geogrid, depending, especially down like on the Cape. I'll use geogrid to give me that structure needed. But you never want to compact the native soils because you want that water to go through it. So, I mean, I don't know if that answered your question, but I will, in these situations, and especially like with pavers, oftentimes, I will use something underneath, especially if the soils are unstable, because, you know, the first thing that's going to happen is if that gravel starts to settle, then your surface is going to crack. So you need to make sure that this is compacted in like 4-inch lifts all the way up. As you're doing that, you know, 1.5, you're compacting that in 4-inch lifts. Then you either get your choker course or not, and then you're putting this on. But you have a stable surface built from the bottom all the way up, and you usually do really well. Like I said, I started putting geogrid, especially under pavers, once I built on some relatively, I don't want to say too unstable, but on some unstable soils. What happened was the gravel just started to migrate down into the soil and my paver started to dip. So ever since then, I've just been real cautious about making a nice solid, unforgiving base, I guess.
Thank you.
And I built it up.
Thanks.
Does this meet ADA compliance for the smoothness of the surface after?
Yes. Yes, as far as I know. I haven't actually installed an ADA compliant walkway, but I've seen it designed in ADA walkways. So yes. Pervious concrete uses Portland cement. So if you just saw it, the concrete will take a heavier load than the asphalt as far as vehicle traffic, etc. So if you were doing, say, like a loading dock area or something, that would be, you know, your choice to put there. You want to use the Portland cement as the binder. It consists of calcium, silicone, aluminum, iron. I mean, cement itself, you know, much of this isn't exactly sustainable at this point, but these are the things, especially where we're not using sand here. Sand is definitely not sustainable. And then the admixtures to pull it all together. And like I said, it takes longer for it to cure. Now, for pervious concrete, again, what my way to around that was, and you'll see in the next presentation, I work with a company that has preformed, they'll do preformed solid, essentially pavers, that you can put down. So I'll order those and get my pervious concrete like that in like 4x4s or the like. Permeable pavers. Next to the asphalt alternative, what I do the most of. The pavers will definitely allow for higher speeds, heavier loads. They are essentially probably the easiest to care for, yet the hardest to maintain. So with the permeable pavers, just like the pervious asphalt, salt's going to kill these. Not saying you can't use salt on them, but you're going to significantly shorten the life if you start putting salt all over these. You can never sand as far as winter is concerned. Pavers are great because if one does break or something goes wrong, it's real easy to replace. As far as maintenance is concerned, though, when you vac the pavers, you don't vac the pavers seasonally, or at least I don't recommend vacuuming them seasonally. I usually do it every 3 years, because what you do is you're going to vac out the joints, the joint sand or the joint stone. It's not sand. You vac out the joint stone and then replace that. And that's how you maintain the porosity. Pavers are also not, they're not as pervious as, say, concrete. I don't know the exact percentages, but let's just say the concrete's like 95. These are down in like this high 70s, 80 range. So they are not as pervious, but they are definitely more stable, better to look at, etc. You're going to have a triple, kind of like a triple stack base on this. You're going to have your number 2s down on the bottom. Then you have your 57. So you're going to have your 1.5 inches, your 3/4, and then your 3/8 essentially on top. The 3/8 is the bedding layer. So if you are doing a standard paver application, normally the bedding layer would be sand or stone dust. You never use sand and never use stone dust. What you use is a crushed 3/8 stone as your bedding layer to lay your pavers in. And then you'll use either a number 8, so you'll use that crushed 3/8, or you'll use what's a number 9 stone, which is essentially stone dust without the fines, as your to fill the joints as your grout, or your joint stone. And like I said, that's what you are going to then, when you vac these, you're going to vac all that out and then need to put that back. What happens is these things go in, nothing happens, and then dust, pollen, road sand, whatever, ends up eventually clogging these joints. However, again, this is relatively easy to clean out. So here's your permeable paver stack. You have your thick aggregate, your larger stone, topped by your smaller stone, then topped with your base. Then you put your pavers on top of that and put your smaller stone back in. These are, these are the bases. Depending on how deep your base is going to depend on how much water you're trying to hold and infiltrate. It's also going to depend on the load that you are looking to carry. So what you would do for a residential driveway or something that's going to be holding like a Prius and a car is going to be very different than what you would do to put in a parking lot that will hold, you know, dump trucks, trash trucks, etc. So the heavier the load, the deeper the base needs to be, and also for the amount of water storage. And I'll actually show you that in the next presentation. The under drain is optional. I've never installed these with an under drain. And you can see here that the geotextile, again, is an option if you need to secure that base.
Have you worked with the pavers that themselves rainfall soaks through rather than the joints?
No.
No. Okay.
Except for the Pervious concrete that I have pre-made for me. So it comes in blocks, which is, I guess, could be like a paver.
Yeah.
In the way it gets set down, but it's not the actual pavers themselves. I've worked with the open cell, not the diamonds, but I work with an open cell paver, and I'll show you that. So I've worked with almost any kind of paver. I've worked with the big diamond ones, which I don't like. I've worked with the open cell ones, and I've worked with every style of decorative paver possible, because I've done it on so many different applications. The plastic grid system. This mostly, as far as the plastic grids are concerned, this is great for overflow parking. I'm trying to think in a municipal situation. I mean, I've always put this in where, you know, this, and there's another product that I like even better, but I put this stuff in when people are like, hey, I need an extra parking spot when the kids come home from college and we have, you know, 4 cars here instead of just 2, and we need to pull off. Or I've put this in areas where people are like, yeah, every now and then I have to, you know, get to this part of my property, but I don't want to create tracks. I've designed this for areas, but it never went in just because of costing, for essentially like field parking. Like there was a field that, you know, that people wanted to be able to have, you know, parking happen, like a ball field type deal. But they want to be able to have an area of it that you could drive out on, etc. The whole idea behind this is that the grid is going to take and disperse the weight of any vehicle, so that you don't get ruts, you don't kill the grass, and you don't compact the soil. So we're back to the inch and a half, 2-inch aggregate base, the choker course, and then we have the grids, and the grids can be filled with either like a 3/8 crushed stone or a sandy compost loam, if you're going to end up planting that up and putting grass and turf in them. So just to kind of recap: porous asphalt, aggregate base, choker course, then the asphalt. Pervious concrete is aggregate base, no choker course, then the concrete. The permeable paver is the number 2, number 57, and number 8 stone. So you don't have to worry about a choker course at all, because that's just the 3 layers of stone. And then the grid system is the aggregate base, the choker course, and the grid. And that grid can either be filled with the number 8 stone or a sandy loam if you're going to plant it up. The construction sequence for permeable pavements. You're going to ensure that the entire drainage area is stabilized. Check for utility impacts prior to excavation. Excavate using the smallest equipment possible. And if you need to excavate in sections so you're not compacting the area and not actually in the hole, then that is one way to do it. If you don't really fully understand what I'm saying, is you would excavate, say, an area, say like a 10 by 8 area, and then you would kind of drive to the end of that and excavate the other side, 10 by 8, kind of the reach of the excavator, and then you would take out that little land bridge that you did in between. You'd back out and you'd kind of do it in blocks with a land bridge in between so that you're not driving up and down and all over both sides. Again, it's just kind of being smart. It's the operator being smart and trying to make the smallest footprint. And for that footprint, you're going to try to reuse the same track as much as possible, rather than driving all over the place. Consider breaking the excavation into cells, allowing that smaller equipment to work with the berms. Scarify or till the native soils to a 3 to 4 inch depth. Install the filter fabric on the sides and or the bottom. So we're never putting the filter fabric on the bottom of a bioswale or a rain garden, but here we want to have the filter fabric on the sides and or the bottom. And if you're putting it on the bottom, what you're doing is you're ensuring that that gravel is not going to migrate down into the native soil. I mean, if you think of any, say, like pea stone path, either at your house or that you've seen somewhere, eventually that pea stone just works its way into the soil and you just end up with like rocky dirt on the top, and it needs to be refreshed. So if you have a cloth layer down, you will ensure that that stone is not going to migrate into the soil. Install the base layer using 6-inch lifts. I said 4. Use a vibratory roller for compaction until there is no visible movement. The depth of the aggregate depends on the structural and water storage needs. Again, I usually over-engineer for more water storage. If an under drain is used, allow for aggregate to cover above and below the perforated pipe. You usually want to have at least, at least 6 inches off the bottom. So you'd have 6 inches of aggregate, then put down your perf pipe, and then make sure you got about a foot above it in compacted stone. Here's just the construction sequence. You're going to excavate the area. You're going to lay the stone. You're going to compact the stone in those lifts to make sure that you have a solid base all the way up. For those who haven't built any of this or who don't know, like if you were to put in 18 inches of stone and then put the compactor on top, there will still be settling post-construction because you're not able to settle out all the stone down on the bottom. So as you do it in lifts, you put down 6 inches, compact that hard. So it's like a stone dust, say like a stone dust walkway, put it down again, compact that hard. Then you're going to ensure that there's not going to be any settling or aggregate moving due to vibration as say like cars drive over it. That vibration over time, if you haven't compacted it right, you're going to get a little bit more settling. So this is a way to ensure that you have a nice solid base. If you put it all down at once, you can't make sure that you're compacting the bottom. Porous asphalt considerations: install the aggregate base, install the choker course, compact the choker course with a 10-ton roller. I am going to, normally what I've been doing via these Zooms is I have a whole ton of links that show kind of installation of pervious asphalt, etc. They were videos that I would show. For instance, if the classes were ending early, we'd watch some of those videos. I might try to show some. It hasn't gone as well on Zoom. So what I've been doing is sending the links, because you don't need to watch the videos to pass the course. They're really designed just for additional information and to fill the time. But people just fall right to sleep watching these videos because they're not riveting whatsoever. It's been painful on Zoom. However, I can send the list of all the links for what they are if you want to look, and that way you can follow up with the links that are relevant to what you care about. So there are links that go to failed bioswales, and there are links that go to the construction of bioswales, and asphalt and green roofs, etc. So I think what I will do is I will send those out unless we really do have an entire day to kill, and then in which case I might just watch you all sleep as I play you videos for the entire time. But the asphalt, you do want to compact. And like I said, the concrete, you do not want to compact. So the asphalt you're going to hit with the 10-ton roller. With the pervious concrete, you're going to install the aggregate base. You are going to screed the concrete just like you would any other concrete. You're going to hand trowel it, but as you're troweling it, you are not going to push down. You do not want to squeeze it out by any means. Pavers. Pavers get screwed up the most because essentially the whole paver process, aside from the aggregate, the aggregate base, the paver process is not any different. And this is why people feel like oftentimes contractors, what I found the mistake being is they think that because the paver is, because it's a permeable paver, which means that it has joints designed to allow water to pass through it. So because they have a permeable paver, what they do is a traditional installation, and they think that because the paver is permeable, the whole thing's going to be permeable. So they put in permeable pavers and stone dust, in which case you've just negated the whole process. But this is where, because it's so familiar, there's oftentimes a misconception. And because people don't understand, and maybe now a little bit more, but all the failures I've seen, and when I've talked to contractors who have failed to do this properly, their excuse has been, well, I put down the permeable paver, not understanding that that actually means the entire. For the installation of permeable pavers, you're going to put down that number 2 stone, and then you're going to put down the intermediate layer of the 57 stone, compact all of those in lifts so that they are firm and unyielding. And then you're going to put down that bedding layer of the number 8 stone and install the pavers as you would any other paver. And then you are going to fill the joints with that number 8 stone. For the plastic grid construction, aggregate base, you're going to install the grids. They all go down, each depending on what kind of system you get, they all go down differently. Some roll out in a giant blanket, some go down in squares. They're all relatively the same. The ones that I'm going to show you, you may or may not have seen. Drivable grass is my favorite, and that's essentially like tiles. They're like little cement tiles. Like if you get a big square of them, and they have lots of little cement tiles on them. So it's a concrete version, but it's extremely sturdy. It's extremely easy to install, and I like it. I'm not adding more plastic to the environment. Not that cement is much more sustainable, but I usually use it because I like the way it looks, and I don't necessarily like to always be adding plastic. And I feel like everything I do adds more plastic to the environment. If you are filling the grids with aggregate, it should be slightly above. Eventually, it's going to settle out, especially if you're using aggregate. Even more so than like grass or clover, you are going to see these. It's not going to be invisible, especially with aggregate, as you saw in that earlier picture. The grid will come through. So this is a utilitarian thing, like for a walk down to the public pond or something of the such. But it is not like, this is not what I'm going to build in front of your house if you have me come over. If using grass, make sure the media is installed just below the top of the grid, and you want to have a quick draining, either a sandy loam, or you can work some of that 3/8 and do like I think I mentioned the structural kind of mix that I use is a third like loam compost mix, a third leaf mulch, and a third gravel. And for this I would use 3/8. Normally I'll use like a 3/4, and that usually gives me a relatively compaction resistant mix. Inspection and maintenance. How do you know your permeable pavement's not working properly? Well, there is puddling. Puddling and or if you have weeds and things growing out of it, it's going to let you know that those pores are clogged. When working properly, the water just pours right through it. when not working properly, you have cracking and settling, etc. If you have settling on the pavers, you haven't done the base right. If you have pretty much any settling and cracking, it's because you haven't done the base right, or the pores are clogged and now you're starting to get frost heaves because excessive fines in there and excessive fine buildup in the joints or in the pores, say it's for a pervious concrete. You know, if you have excessive fines and that starts to retain water, then it's going to expand and crack during any of our freezing. So it's just, maintenance is the whole thing. And I understand, like, maintenance is the biggest pushback that I get, but everything we do, we have to maintain. All of the roadways, sidewalks, storm drains, and everything you have now, you maintain. So this is just a different system that requires different maintenance. But it's not like you don't maintain anything you have now, and now all of a sudden this is a system you have to maintain. That's like the argument that frustrates me the most, because it's just, yes, these need maintenance. It's absolutely true. And yes, they need a different kind of maintenance than what you may be set up for. But don't front like nothing gets maintained, because I know pretty soon the highways are going to be all orange barrels because they're maintaining the potholes and everything else. I mean, maintenance is a thing. Everything we have, every system we have needs to be maintained. Like I said, putting in a GI system, think of it like putting in an HVAC system. Think of it like your car. It's like there's a whole thing that has to work. And if you want to work properly, you need to change the filters. You need to inflate the tires. You need to make sure the belts aren't cracked or whatever if the car is going to go. With the HVAC system, you need to change the filters. You need to make sure that the intake isn't clogged if you want that system to work well. So it's a system. And if you want it to work, it needs some inspection and it needs some maintenance. Ultimately, what I would love to see is that inspection and maintenance turn into new jobs. Ultimately, what I would love to see, especially, you know, in the commercial and residential world, is to have crews that just do green infrastructure maintenance. Like you have lawn mowing companies that pretty much just mow your lawn and, you know, do your fall cleanup. I would love crews that just did your permeable paver sweeping and your bioretention cell cleanouts and maybe your green roof maintenance. I mean, like, ultimately, if we can get enough of this in, somebody can absolutely make a living just doing that. And they can buy the equipment and you can just sub it out to them. The maintenance, like I said, with the pavers, it really depends on the conditions and how quickly those pavers are going to fill. I just had somebody contact me about wanting to do a permeable paver installation on the beach on the Cape. And I was like, no, don't do it, because it's all sand. It's going to clog. It's not going to work like you want it to work. And you'll have to be vacuuming it, you know, constantly to make sure that it's working. Would it be beautiful? Absolutely. Will it function for years on end? Definitely not. Not on a beach with blowing sand and driving vehicles and everything. It's just not a thing. Best thing to do, like I said yesterday, I am out in the rain all the time, either checking projects that I've done, checking projects that other people have done just to see how they work, and documenting stormwater moving through and on gray infrastructure and standard systems. Want to monitor the infiltration rates, the standard test method. If you would be using the, you know, an infiltration method using the single ring, an average of 3 test procedures must be performed for every 25,000 square feet, and the average is taken of the 3 tests. I have a video, if I can find it, I will either show it to you today or coming up. It's 5 gallons in 30 seconds going through pervious pavement. If present, use observe the observation wells, check the observation wells, make sure that you have no standing water. You know, this is great for a paver, a parking lot installation, or, you know, if you're questioning, if there's any question that water is infiltrating into the native soils, or that the that there is maybe any change in the groundwater levels. Just to make sure, because if, that should be totally drained out 48 hours after a storm. If you are still, holding water in that gravel 48 hours later, something is wrong. But that wrong is something's wrong with your base and your subsoils. Something was missed if there's water in the gravel 48 hours later. Maintenance and safety, have a traffic plan, have a pedestrian plan. Communicate with materials. This is the big one. Permeable installations need to have clean stone. You need to have clean aggregate. You need to order clean aggregate, and you need to make sure that that aggregate remains clean right through installation. If there's topsoil and that aggregate, like we talked about, if they blend together, that's bad. If you're using a bucket, if that bucket is moving the topsoil and then he comes over and picks up a thing of aggregate and dumps it in for you, that's bad. So you want to make sure your machines are clean. You want to make sure your materials come clean. If they don't come clean, you need to clean them before you use them. So here are the vacs. Vacs and street sweepers used. The walk behind is what I use most. So a walk behind vac for the size installations, and from what I see, that's what gets used most. The truck, I haven't had to use one, but I've seen the situations where they need to be used. $250,000, I don't have it, so I can't even get myself. Identify and stabilize any sediment sources on pervious areas. I actually have a picture that is almost identical to this in North Andover. They have this parking lot that has numerous types of GI applications. They have pervious pavement, they have bioswales, they have a bioretention cell. They got it all going on. However, they did not stabilize any of their planting beds, so that just washes right out onto the pervious pavement. It just flows right down into the biocell. So it's like, at installation, I'm sure it was gorgeous. Overall, does it work? Sure, absolutely. But does it work as designed? No, not at all. And part of that is because the maintenance crew that they have there just keeps adding mulch on top of mulch on top of mulch. And that's what happens when you fill your beds with like wood chip mulch that doesn't break down fast enough. You either have to take it out or you have to leave it for a couple of years, but you can't just keep adding it, because eventually you get this giant thick layer of mulch, which isn't good for the plants, but it's also in a situation like this, you've just created a layer that's going to spill or wash out or blow around, and that will jeopardize your system.
Hey, Trevor.
Yeah.
I don't know if this is the right place to ask this, but that made me think again about the suggestion to use porous pavement for rail trails. How do you separate these areas, which are admittedly often very close to resource areas, from like having stuff wash over the porous pavement?
Well, you'd want to start by making it raised a little bit.
Okay.
So, normally from the rail trails, that I've seen, been on and bid on, the idea is to have it sit proud of say like all the leaves and all the whatever on the side, 4 to 6 inches, 4 inches, and just have that slope down. So it sits proud of the dirt. If you build it flush, then you're absolutely right. Everything's going to just go on it. It's going to be harder to maintain it. Ultimately, say with the rail trail, being 100% realistic, even with maintenance, it is never going to be perfect.
Okay.
With all that organic matter and everything else, and people running on it and biking on it, and with all that activity where it is, and the amount of funds that I'm sure will be allocated to maintain it, it's never going to be perfect, but it's going to be better than if you put in straight asphalt.
Okay. Thanks.
And I believe in the long run, because the water will, because of the base And because it's porous itself, you'll have less cracking, so you won't have to like get a crew out there to fix cracked asphalt in the middle of, say, the woods. So it will also be, if you have it cleared off, if it's a rail trail that gets cleared, say in the winter, great. Otherwise, if not, it will hold less snow. Here in Arlington, people are on the path all the time, and essentially and eventually like mid-January, you get like 3 inches of ice just over the whole path because it all gets packed down and melts, and it just stays there and doesn't go anywhere. So, being realistic, if you put it in, it's 100% 5 years from installation. Is it going to be 100% even with maintenance? No, but it's going to be a whole lot better than, a standard installation, and will last a whole lot longer, even in that environment. Inspection and maintenance, typical maintenance tasks: removing excessive moss or other plant growth, using pressure washers, weed burners, or regular street sweeping equipment. So the pressure wash thing, so a wash vac is something that I think works well. Oftentimes what I'm told by manufacturers is just go ahead and pressure wash, say, the concrete, or pressure wash. I mean, I've heard them say pressure wash the asphalt. Essentially what you're doing is you're just pushing the fines through. So you're essentially going to end up clogging the base to an extent. So I'm more for the air vac, the wash vac type deal, to get the fines out of there rather than just forcing them through. You'll still, retain porosity, but eventually over time, let's just say we're talking 15 years. Eventually over time, you're going to reduce that. If all you do is just keep pushing the fines through the holes, you're going to eventually kind of clog the base, especially if it's another aggregate like a sand. If it's organic matter and you're pushing it through, you'll get away with it longer, but you don't want to end up creating soil there in your aggregate either over time. Snow removal, salt can be used on permeable pavements. Once you do that, though, what's happening, I mean, I guess either way, but when you apply salt to, like we said, to the pervious concrete or permeable pavers, you're going to reduce their life. And you also have to just know that that salt is going to then infiltrate instantly, like 12, 14 plus inches down, 2 feet down, whatever it might be. So when you're using salt, you're definitely introducing it well into and below the soil horizons, where normally it's all on the first, say 6 inches. Now you're infiltrating it 24 inches down. If you do that and you're in an area that has a fluctuating water table, well, then you're just going to kind of keep pulling that salt further and further down into the water table. So it's just things to consider, because oftentimes these are installed and are perfect for areas where you have a high water table or a fluctuating water table. And again, if you're putting that salt 2 feet into the ground already, and that groundwater comes up and then recedes, it's just going to take that salt with it. So just things to consider when you're considering maintenance and what maintenance. Like I said, I can usually achieve this with just plowing or snow blowing alone. This is what it'll look like by 10 o'clock. There are certain areas that, like I said, are heavily shaded in urban areas where it's like heavy buildings. It's all shade, north side, then yes, sometimes I need to put down something to make sure that it dissipates a little quicker. Replacing the gravel and the plastic grids. I'm just going to need to, to really top that off, make sure that the grid itself is still in place. And then as that gravel either works its way, way down, or gets kind of tossed out over time, you're just going to need to top it off as needed. Maintenance, when you're addressing maintenance, and so if you design something like this, it needs to be stated so you cover your ass. If you manage GI facilities, you just need to constantly be aware that people are just used to, say, dumping a load of mulch on a parking lot, or dumping any kind of material for any other construction needed. You know, you may be building a berm, you may be doing some mulch, you may be doing whatever. People are just used to dumping their materials in parking lots, in parking spaces, and it's just something that it has to be brought up and has to be said, because if somebody comes along and dumps a load of loam or a load of mulch all over your permeable parking lot, then you are going to have to at least vac that area, if not the whole thing. And that's just, you're incurring an expense that you didn't need, or you're just going to, like Dedham, just be like, you know what, forget it, we don't care. And in which case, why did you put the GI in the first place? It only works if you follow through with it. Pavers, replacing broken pavers is really the thing you would do. For pervious concrete and asphalt, here's kind of the answer to your question. You're going to need to kind of cut it out and fill it. Like I said, I don't know enough about the porous asphalt to know if you can just do a small patch. As far as concrete's concerned, I know you do a big enough area that you can screed. You don't just put in like a wheelbarrow's worth. You kind of do a large enough block, like a 2x2 or a 3x3 block, to put in, if need be. In which case, having somebody mix that up for you is harder. Cleaning, you just, again, without cleaning, these will not work. They will eventually clog and become impervious or semi-impervious. This, I guess, is better than nothing, but again, don't go through the expense and the time of putting this stuff in if you're not going to maintain it, because then it is just a waste of money. You can put down, standard asphalt at what, $5, $7 a square foot. You'll put down a permeable asphalt at $12, $16 maybe a square foot. So, if you're not going to maintain it, if you're not going to see it through, then why spend double the money on it? Clogging permeable pavers, again, they're saying pressure wash. I say vac. I say vac every 3 to 5 years, depending on the situation, depending on how quick these things clog, and that requires inspection. So I will go and I look at these systems that I put in, and if I see the water pooling, or if I see that it's running down down a driveway or pooling in a parking lot, then it's time. That too much has gotten in there. So 3 years is usually a good mark. I've found. For the asphalt alternative I'm going to show you, it needs to be, vacked on the regular, but usually about every 3 years, you're going to need to reseal it. And that brings us to the end of that. Does anybody have any questions regarding permeable pavements?
I have a question about the exam. I understand why you're saying to vac instead of power wash. If there's a multiple choice question with what do you do, should we choose power wash?
Yes. If they ask what to do, say what we go over on the slides. Okay. So yes, and this is where I'm sorry, I get a little confusing normally, and I haven't been this class. Normally I say for the test and for what I find. And I haven't been differentiating that enough. I've been kind of talking to you like we're going to install this next week. So yes, for the test, pressure wash, pressure wash and vac for pavers, and for all pervious concrete would be acceptable methods for cleaning. Any kind of scrubbing, you want to make sure that the mosses, any moss is scrubbed off. And you want to make sure that the pores are clean, and that can be done with either vacuuming or pressure washing. But like I said, so out of the test, I've just found I don't like the idea of pushing the fines further into the system. I like the idea of getting them out of the system. So it is exactly 10:20. Why don't we take a 10-minute break? We'll come back. I will set up this PowerPoint, and we will go over that, and that should be fun.
Hey, Trevor.
Yes.
One thing on the porous pavements here, are we sort of missing the big picture in some locations? You mentioned the application at the beach. Now, the whole purpose of porous pavements is not to concentrate stormwater so it creates erosion in the streams and whatever. You want to dissipate as much into the local ground surface as possible. When you're on a flat site, like at the beach on sandy soil, all you have to do is let the water run off a sidewalk, and it's gonna infiltrate. It's gonna go into the same place it would go as through the pavement. There's no point in putting a porous pavement in an application like that.
Exactly.
You're accomplishing the same thing by putting in a conventional pavement and eliminating the extra expense of the porous pavement.
100%. This is where I'm talking about how we need to look at green infrastructure, and just because we have a grant or just because we want to put green infrastructure in, you need to think it through. And that was the exact conversation I had on with all that. I'm like, there's no point in installing, especially pavers, but there's necessarily no point installing any sort of a pervious pavement, in a beach location. And I understand they wanted to eliminate runoff from the parking lot, okay? But essentially, like you said, once it runs off the parking lot, then it's going to infiltrate anyway. If anything, I would do a modified, say, swale or a modified bioretention cell. And by modified, because it's, depending on where you are, and if you're messing with dunes or whatever, but around the immediate parking lot, I'd do something where the water would kind of catch to help just to help try to eliminate erosion, to help that water from making it too far, say, into a natural area. Because the water coming off the parking lot is going to be, it's going to have a toxin load. But you're absolutely right. And this is where, like I said, this is where it comes, the biggest mistakes I'm seeing are people putting in GI just to put it in, and people putting in GI who don't fully understand it, but, like an architect or so, who's just excited to have the opportunity to design it. So it's just like, and we need to come together. And if, like, you have the opportunity to design it, you need to understand it. And if you have a grant to put it in, you need to think through that grant. And part of thinking through that grant needs to be, how is this going to be maintained? So yes, I have money to put in a bioswale. What about maintaining that bioswale? Because then it's just a great bioswale that's going to go to crap over the course of the years. So, like, part of the grants that, this is why I have a love-hate relationship with grants. Much of my work is funded by grants, but much of the downfall to those grants and what I try to work into those grants is what's going to happen after. So I either try to allocate money or instantly set people off trying to find money, for grants that will maintain that. Or part of the grant money is bringing in whomever. It's part of the training. So part of the training is to bring in whoever's going to take care of it. So if it's like part of that grant money then offsets the time that I need to speak to a parks crew or a DPW crew and train them how to do this, then some of that money is set aside. So it's not whacking into anybody's budgets, because I know the budgets are tight and I know that's a very sensitive subject. So when you get that windfall of that money, I try to use that to the best of my ability, try to make the biggest splash, try not to piss anybody off. But I need to ensure that once I'm gone, that all these things are going to be executed. Because I went back 2 years ago, I went back to this rain garden that was like the best thought out thing that I could have imagined, and nobody's touched it since. You can't even really tell it's there. It's just a grown up area. It's absolutely disgusting. I don't know what happened to the money that we set aside for the maintenance. Somebody obviously walked with it, or he used it on something else. But all you can do is try. But, these things need to be set up for success. So right now, in having my discussion with the people who handle the MVP, like, I'm really excited about all these MVP grants because it's allowing all of you to put in either your first or multiple, green infrastructure projects that you may not have installed otherwise. That being said, you need to have a plan on the other end. Otherwise, again, it's just a waste of money. It's a whole lot of effort and a whole lot of product for no reason if you're not going to maintain it.
Well, you bring up a great point because that's what we get saddled with. We have a school that has great bioswales, but we don't have the staff to maintain it. The parents don't understand it, even though there's signs out there. So it gets mowed down once a year, and they say that animals can hide in there and things like that, and it hasn't been maintained. And nobody thinks about this through that. You get through the first year with maintenance, and then it's just we lose staff, and as budgets, they're not going to give us the equipment and time to do it. And it is a great idea if we could follow through, but there's never the follow through, unfortunately.
Right, and that's usually, in discussions with any DPW that I've had. Usually, there's two types of people, like yourself, saying, "I'll absolutely do this if you support me," and other people being like, "No, that's stupid. It's not going to work." And I have no patience for no, that's not going to work, or no, I'm not going to do that because that needs maintenance. Because like I said, everything needs maintenance. So don't throw that at me. You can absolutely, and it's a very fair argument to say, you know what, you got to, if we're going to do this, if we're going to make this shift, then you got to support me. If I'm going to go on this diet, then you can't have the fridge and the freezer full of, ice cream and everything else that's going to kill me. If I'm going to do this, then we're going to do this. But we have to make that shift, and you can't just keep, filling the pantry with all those things, using the same exercise thing. If you're going to buy the treadmill, it's great to buy a treadmill. It's only a waste of money if you don't use it. As long as you're using it, it's not a waste of money. So as long as you're building and maintaining these things and using them, then it's not a waste of money. But to go and to put it in and then not use it or not maintain it, it's a total waste of money. And that's where, the conversation needs to change. That's the exact conversation I'm having on Friday with the EPA is where's that next support? Where does that next thing happen? It's great that you're giving people grants. That's wonderful. But then what? It's great that you want to install permeable pavements and bioswales, but how about who's going to maintain it? And how about, is part of that grant, is it just the municipality that gets the grant that needs to set aside money for the maintenance? So whatever it might be, if you get $50,000, do you need to set aside half of it to make sure that that thing's maintained? In which case you can't achieve as much as you would in the beginning. Or are there going to be supplement grants to make sure these things are maintained? It's kind of like I liken it a little bit to changing a farm over from conventional to organic. There's an interim in there, and that's why many conventional farms won't go organic, because you're not going to get paid to become organic. You need to be not using chemicals for like 3 years. So for those 3 years, you're going to be growing produce, making conventional ag prices and not the the premium organic prices. So then farmers in the middle lose their ass because they have to put in expenses and change their ways and do all these things to go organic, but that interim's not supported. So if we're going to go GI, then the interim needs to be supported. Otherwise, we can't make that transition. It's not a smooth cut. It's not a clean cut, a smooth transition. So we need to find the support, and where it's lacking, from what I've heard from you and many other people that I've talked to, what we need to do is we need to fund or grease the transition so it's a smooth transition from doing what we did to doing what we want to do. But you can't just start doing it. You can't just cold turkey GI, and you can't just one-off GI, because it certainly won't work. So,
if we have time, it would be great to have a conversation around that, with all the people in the room about like what kinds of things would most be helpful. Like if it's about having that help on your staff or having crews of people in the region that can be sort of circuit riders in maintaining projects. You know, how we establish a pool of funding for that kind of stuff. It'd be great to see what ideas are in here, you know, provided we have time in this training to do
We
that.
absolutely have time, and I would love to have that conversation whenever. We can have it now if you'd like. I mean, we can have it like, you know, the last day, you know. But I mean, if you want to have that conversation, I'll write it all down, because like I said, these are the conversations that I try to kind of, I am right now kind of acting as and trying to act as a go-between, you know, because I am a face and a voice that hasn't really fully pissed off either party. So it's like I can go to the EPA and talk to them, and they're not going to just instantly shut down because they think I'm squawking or they think I'm going to want more money. I'm a neutral party, and I can go and I can, you know, I've talked to municipalities more often than not. I mean, I've been sitting down over the course of the winter and discussing GI, and it's not what everybody wants to hear always. You know, like I said, people want to hear me say, rah, rah, let's put in 1,000 trees. And like I said, I don't say that. I say, let's put in 200 correctly. You know, so it's saying that, and it's not always what everybody wants to hear, because everybody wants to do this. But like I said, it needs to be successful. So, and I want to see this happen more than anybody. You know, I want to see those 1,000 trees go in, but if I have to drive through and see, 998 of them dead, that's going to kill me. So, you know, like I said, I'm really big on making this a sustainable practice, as much as I hate that word, but making this a sustainable practice, making it so, you know, and getting it to the point where, you know, Chris has built into his budget GI maintenance, you know, where, you know, it's not part of the budget yet. So we can't have we can't have the people of the town being like, we want more GI, but we're not going to give you any money to maintain it. That's not fair. So that's where, like, I sit down with those people and say, that's not fair. You need to give more money. You can't say, here's the same $10 I gave you last year, but I want you to, you know, step it up with all these new practices. That's not a thing. So it has to be factored in, and you have to fund the transition and make it happen. That being said, once we're on the other side of it all, a lot of this takes a lot less maintenance. A lot of it is, you know, overall a lot easier. The equipment, aside from like a vac truck, the equipment needed, like what's needed for a bioswale is a whole lot cheaper than having to go around and dig out, you know, storm drains all spring long. You know, I haven't done it hours to hours, so I don't have that hashed out, but I have to believe, watching the trucks drive around Arlington for like a month, digging out storm drains, I think it would be a lot easier to send out a crew just to do a simple spring cleanup in a bioswale. You know, it's got to cost less. And, you know, you're disposing of organic matter. And again, all the additional costs from that, because now you've taken a whole lot of pressure off of those storm drains. You've taken a whole lot of debris out of the existing storm drains. You've taken a whole lot of chemicals and everything out of there. You've added cooling. You've added carbon sequestration. You've added habitat. You know, there's all these benefits that we haven't quantified yet, that we haven't put dollars and cents to yet. You know, that part's still tough. And people aren't going to, you know, people don't necessarily see the value of a bioswale. It looks like a pit with a lot of pretty plants in it, until those pretty plants are full of weeds, you know, until it's full of weeds. But I mean, just people don't see that as a functioning system. It comes with education. You know, I advocate for signage all the time, or, you know, or some sort of education, you know, so the people have to be made aware that it's actually a thing. Otherwise, nobody's going to recognize it. You know, your rain garden could be a pollinator garden, but if you don't tell anybody what it's doing, then nobody knows. It just looks like a pretty garden. And that's all people are used to. People look at plants and they think it's that. They're not seeing it as a system. They see the pavers, pavement gets treated the same. You know, they're like, oh, we don't have to do all that to our other pavement. And you'd be like, no, you didn't, but you asked for something different. It's not apples to apples. You know, if you want something different, we're going to have to treat it differently. It requires a different process. That's all. And like I said, it's just it's the frustrating in between that we're at. Did those who stayed on want to take the last 5? We'll do it and we'll come back at 10:40. Yes? Okay. You are here exactly where you need to be, because you are exactly in the right place, because it means you are thinking about green infrastructure and stormwater management, which is what we need to be doing at this moment, because green infrastructure and stormwater management not only will clean up our waterways, but it is also, as I will touch on briefly, but can get into at a different time, is also very much the answer to climate resilience and offsetting climate change. Water is H2O, hydrogen 2 parts, oxygen 1. But there's a third thing that makes it water, and nobody knows what it is. Now, what made me fall in love with water, or one of the things that made me fall in love with water, is that it is at the same time part of our daily routine and part of everything that is just magical and beautiful with the world. So we all got up, we showered, we made our coffee, we brushed our teeth, we drove to work. We are literally, everything we've done, the lights that are on right now require water. Everything that we do, we are literally bathed in water, and water is just, especially in this country, it is always there for us. We turn on the faucet and water is always there. We actually do not have a term really for what it is like to have no water. When we have no power, it's a blackout. When we have no water, it's just kind of creepy. I mean, any of you who have ever opened up a house or have a cottage or something, when you go there and anytime you turn on the faucet and no water comes out, it's kind of there's a second there that you're like, whoa, because we're just used to it. However, that being said, anytime you are just on a walk in the woods, on vacation, and you say you come across a waterfall or a stream in the woods, you can't help but just stare and just be taken in by that water, or somewhat feeling connected to the water. If you're on a beach, just watching those breakers roll in, you just can't help but be taken away by the majesty and all that is wonderful, of that water. And that's one of the things that makes water so special to me, and that I find so powerful about water. Over 50% of the water on the earth is actually older than Earth itself. Really, 100% of the water on Earth is older than Earth itself. It's 4.5 billion years old, which means that those molecules of water that we drink every day and bathe in and everything else actually existed before there was a planet Earth. Much of the water, say 50% of it, was formulated as all the gases and everything happened around with Earth's formulation. The rest of it came here on comets and asteroids and things that struck the Earth. They actually brought more water to the Earth itself. We call ourselves the blue planet, but if you were to take all of the surface water on the Earth and put that into a marble, it would only be 860 miles in diameter and actually would fit within the continental United States. Put a different way, if the Earth were the size of a Honda Odyssey, all of the surface water would be a single half-liter Poland Spring bottle in one of the 13 cup holders. So we say water, water everywhere, and we think that water is infinite, but our surface water, and especially our fresh water, is actually a precious commodity. As I was saying, all of the water here on Earth has been here since the beginning. So every single molecule of water, every drop of water that is in my glass right now has seen the inside of a cloud. It's been inside of a tree. It has been inside of a volcano, and it has been inside of a dinosaur's kidneys. So we all drink and shower in dinosaur pee every single day. There's no question about it. That's just the way that it is. However, what is a little more romantic and beautiful than that is that a molecule of water in my glass right now, or in your glass, your coffee cup right now, at one point in time could have been a mother's tear as she held her baby for the first time. Or it could have been somebody's last breath. It could have been a bead of sweat as somebody labored to build the pyramids. Water has just been recycled again and again. So not only does it connect us to space and connects us to the universe, but it also connects us through time. So as I said, the first part, why I love water, that's really why I love water. That's exactly what makes me so passionate about water, is that it connects us all to each other, and it connects us all to each other through time. You know, and like I said, through space. When we hear about space, I mean, they're on Mars, but we hear about comets, and we hear about comets and asteroids being covered in ice. I have ice in my freezer. So like, to me, that's just super cool that a comet that comes around and only barely comes into becomes visible like once every 110 years has ice on it. I know ice. I can relate to ice. So that's just amazing to me that we're connected to the universe like that. And like I said, that we're connected to time like this. Now, here's just a little exercise. And since all of you have your cameras off anyway, it really shouldn't matter. But I want you to image water. Now, that's different than imagining water. Imaging water, when I imagine water, or when I imagine, say, a forest, if I imagine a forest, I'm imagining like Lord of the Rings. I'm imagining Narnia. When I image a forest, then I am imaging the woods that I grew up in. I'm imaging the woods at the end of my street. So if your cameras aren't off already, if you would like to turn them off, go ahead. But I want you to take a moment, and I want you to image a rainstorm in a rural area. I want you to picture, where does that water go? What does it touch on its way to the ground? What happens to it when it reaches the ground? What happens to the water a few hours after the storm? How about a few days? What about a week? What effect does that water have on the earth and the soil and the biology in the soil? What effect does that water have on the climate and temperature? How does that water affect the human population? All right. Now I want you to image a rainstorm in an urban environment. Where does that water go? What does that water touch on the way to the ground? What happens to that water once it reaches the ground? What happens to that water a few hours after the storm? How about a few days? Now a week. What effect does that water have on the earth, on the soil, the biology? How about the temperature and the climate? How does it affect the human population? That right there, like I said, sometimes I'm accused of being a little woo, but that thinking right there, that imaging is exactly how I approach stormwater management. It's not a bunch of graphs, it's not a bunch of math, it's not in some sort of a computer model. That's how I start. I image water, and I image what it is doing. So, you know, water, when it lands in that rural environment, how does it affect the population, or how does it affect? Well, it goes into the ground, and it has a cooling effect on the environment. It provides for cooler days. It provides that short water cycle and that immediate moisture. In the urban environment, it gets stuck in the air, and it provides humidity, and it becomes oppressive, and it amplifies the heat, and it harms the air quality. So I image, like I said, and relating to water like that is the angle that I come from. And that's how I think we all need to kind of look at it a little, because it can't all be solved in a computer model. So what is the problem? Well, part of the problem is, since 1980, the number of extreme meteorological events has doubled. So whether you are a climate change believer or not, it really doesn't matter, because no matter what the climate is, or the amount of extreme weather events are changing. The weather is different than it used to be. And what is happening is storms are coming at times, and in water and rain and precipitation is coming in quantities that our built environment is not equipped to handle. Like I said, everything that we need to know about climate resilience is held here, 5th grade hydrologic cycle. All of the answers are right there. And as we've already talked about, so for this class, I can fly right through it. We talked about in the natural water cycle, how we have an exponential amount of evapotranspiration, which will cool the air, fuel the short hydrologic cycle. We also have a whole lot of groundwater that is infiltrating and making its way slowly to our waterways. This right here is an example of the short water cycle. That immediate moisture in the air that is then either evaporated back into the air or makes its way into the ground slowly and is very nourishing. That short water cycle is the most nourishing for plants and for wildlife. Mother Nature designed every single waterway with a flood plan. We came along and we, for one reason or another, because we thought we knew better or because that waterway was inconvenient, we changed that. However, Mother Nature says to us, I actually had a plan for that area. I'm sorry. That is where the flooding occurs, when we have a whole lot of rain. And now we're getting bent out of shape because we have a whole lot of flooding, which I said before is the result of 300 plus years of mansplaining to Mother Earth. Here we have the urban water cycle. It's very similar, much of a good example, because there was just recently on the news about all the houses like in Sandwich on the Cape that were built on the shore that are now falling into the ocean. And people are all outraged because the house that they built right where the waves come crash into the land have eroded away, and now that house is falling into the ocean. Like that should have been a given. Like you should have known that and seen that coming from the beginning. Like there, you have no reason to be outraged. While I'm sure it was gorgeous to live there, the waves have been eroding our shorelines since the dawn of time. Since the dawn of oceans and shorelines, the waves have been eating away at the land. So to build your house right there where the waves meet the land, and then to get bent out of shape that your house fell into the ocean, that's on you. And this is the kind of thing that we've done. Because of our built environment, we've built this environment, and now we have scenes like this. And we're like, oh my God, we have a flooding problem. We don't have a flooding problem. We've built an infiltration problem. That's what we have. And that's what we have to fix. Our built environment, our impervious surfaces, our compacted land, our built environment has created an infiltration problem. And that's what we need to solve. People will say, well, okay, well, green infrastructure. Well, that new green infrastructure you're into, Trev. Green infrastructure is not new. This is Machu Picchu. Machu Picchu is about 800 years old. The Incas said, you know what? We want to build an empire on the side of a mountain. And then they said, well, if we build an empire on the side of the mountain, we're bound to get washed away. So what did they do? They terraced that empire, and they built that empire on different grades of gravel. Exactly what we just saw in the last module that we just went through. Different grades of gravel to expedite infiltration, eliminate erosion, and damage to our structural environment. The Inca did it 800 years ago. They built along with nature. They did not try to build against nature. And that's what we need to get back to. We need to stop seeing things like this. Now, with things like this, and this is, I hope I don't make anybody mad, but with things like this, oftentimes what people say is, it's your irrigation. Yep, that's true. People will say you stay in the shower too long, and that's why we don't have enough water. Yep, that's kind of true too. But we also have things like this. I see something like this in Boston probably every other month. We have old, antiquated stormwater systems and water delivery systems. This right here, you may or may not remember this, but this is a pipe from the 19th century in Boston that broke. The pipe, it's a wooden pipe. It's a wooden pipe from the 19th century in Boston. Can we just all agree that the water demands and that the population in Boston has grown a little bit since the 19th century? What happens is we put all of our water infrastructure into the ground, forgot about it for a long time, and now it's going to cost a whole lot to fix it. And that's where green infrastructure comes in, because green infrastructure is going to buy us time to fix our antiquated infrastructure. 12 billion gallons of water are lost per day globally due to faulty infrastructure. But it's not just on a municipal level. I drove past this for an entire summer. This is just negligence, and this is just a waste of water, and this can't stand either. Because I don't know how I saw this because I'm up early. I saw this because I was driving by here at 4:30 in the morning. However, you can see that the grass in the curb is growing great, and you must be able to see, even the landscape maintenance people must have been able to see that there was a massive amount of water and that the head must have been broken. What it came down to was just not caring. It came down to, we'll take care of that in the fall or in the spring when we start the system up. And they just let it go all summer long. This is an extreme waste of water, and it's unacceptable. So it's not just on a governmental municipal level that we need to be caring about our water systems and how we use our water. Landscape professionals, homeowners, we all need to care a whole lot more about water. The two main issues regarding water are supply and demand and stormwater runoff. Now, at least 36 states currently are in drought conditions, even under, or drought restrictions, even under non-drought conditions, because of the supply and demand and the reduction in the water. Part of the problem is we are not infiltrating, or we are not replenishing our water supply quick enough. And our storm events are coming sporadically in certain areas, or not at all in other areas, and we're running low on our water supply. But I'm here to talk about stormwater. Definition of stormwater, we went over this. Water originating from rainfall or melting snow that runs off across the land instead of infiltrating into the ground. Along the way, it picks up pollutants as it runs across paved and unpaved surfaces. What difference is it if the glass is half full or half empty when the water is polluted? The stormwater impact of tomorrow. This is my mission. This is how I approach this, because you never change things by fighting the existing reality. To change something, build a better model. And that's what I am trying to do with green infrastructure. That's what I am trying to do with my approach to regenerative land care. And that's what I encourage anybody who is designing green infrastructure or who believes in this does, because by just saying to somebody that's bad is not going to change anything. By telling somebody that's wrong, that's not going to change anything. By making climate change big and scary, that's not going to change anything. You have to empower people, and you have to make the old models obsolete. Best example of that is the cell phone. You know, after 2 years, 3 years, your cell phone is way obsolete, and it's time to get a new one. The cell phone companies, computer companies, they all knew how to do it. They just make a new model, makes the old one obsolete. We want the new model. That's exactly what I'm trying to do with green infrastructure. This right here is an image, and so is this, from the Boston 2050. If you remember that, this was like back in 2016. They had this competition where we were designing a Boston for sea level rise. And so what is happening, this right here has canals and gondolas and oyster bays and all sorts of wonderful things to deal with the sea level rise. It's designed parks that will slowly get swallowed up over time, but the parks are designed to just disappear over time. So we're designing for this. We're thinking about this, but the problem is, at least on my end, is that nobody really knows how to implement any of this. We certainly cannot build this if we can't put in permeable pavers properly. So the 5 core methods of green infrastructure that I was talking about will be rain harvesting, permeable pavements, rain gardens, green roofs, and tree plantings. We are going over more of that in the NGICP class, but for this case, this is what I'm handling. Rain harvesting. I'm going to talk about rain barrels and rain harvesting systems. But first of all, why should we rain harvest? Well, life on this planet is directly connected to water. Without water, we die. The EPA has calculated that we use 165 gallons per person per day. Now, that's 165 gallons per person per day. However, we use an additional, each one of us uses an additional 220 gallons of water in electricity consumption alone. The largest consumer of water in our nation is actually energy production. And less than 1% of the Earth's fresh water is available for our use. Just to put things into perspective, 1 inch of rainwater on 1 acre of land is 27,000 gallons of water. That's a lot of water. But 1 acre of land for some people is hard to picture. So 1 inch of water on a 2,000 square foot roof is 1,250 gallons. In this area, we receive 41 to 47 inches of rainfall per year. So when we're talking rain harvesting, that's a lot of water to collect. And in areas like mine, where you pay for water, that's a lot of money falling from the sky. So how can we reuse rainwater? We can use it for landscape irrigation. This is the easiest. These are the installations I do all the time. That water can then be used for washing cars, patios, and decks. Why? We do not need potable water to wash our cars. We do not need potable water to top off our swimming pools and hot tubs. In areas where there are wildfires, if you had a couple thousands of gallons stored, then yes, that would be great. In addition, to protecting your property. And where I would like to get to, that is not available in every municipality that I know, is collecting gray water and using it for toilet and laundry supply. Because we do not need potable water in our toilet. Our toilet water in this nation is cleaner than the majority of the people in the world drink. And that's kind of crazy. So we will start with rain barrels. I have a love-hate relationship with rain barrels. They're the gateway drug to rain harvesting systems, which is great. Rain barrels are also great because they make people aware of actually how much water is coming from the sky, and they make people aware of water conservation and rainwater use. When installing a rain barrel, it is imperative, I think, that you install a downspout diverter. The rain barrel on the left is actually a rain barrel that my friend makes for sale. However, I dogged him for this image because in the winter, when you take away that rain barrel to winterize it, or when that rain barrel is full, but let's just say for the winter, now the water is going to come down the downspout and fall 3 feet and splash all over the ground, and you're going to have a huge mess. So if you use a downspout diverter, what it does is allows you to direct the water into the rain barrel when needed, and then you can close it, and the downspout will act as a general downspout when it is closed. So when you winterize this rain barrel and take it away, your downspout will act as a downspout when it's closed. Now the kicked up version is something like this little R2D2 that you can put on your downspout. This right here has multiple filters in it. It's got a screen filter. It's got a grid filter to slough off the leaves. It's got a screen filter to filter out, say, grit coming off of the roof, any dust or pollen, anything down to 200 microns. And then it also has what's called a first flush diverter. So it's got a little sponge inside. So when that first flush, which is going to have all the dust and the bird crap and stuff that's coming off the roof, this actually allows that first flush to get diverted and go down the downspout. And then as that sponge swells, it begins to divert the water, the cleaner water, into your rain harvesting system, or whether it be a cistern or a rain barrel. So here's just a perfect example of a rain barrel installed with the downspout diverter. We will be coming back to this project, but it's all very easy in the terms of rain barrels installation. Now, when we want to kick it up, because rain barrels are only going to hold 50 to 75 gallons. So if you're looking to hold more than 50 to 75 gallons, we need to get into something bigger. We need to get into tanks. And this is more of all the stuff that I get into. So here's just an example of some tanks that I did not install. I had to replumb them because they got installed and plumbed improperly. The reason I am showing you this is if you've ever tried to mask an AC condenser on the side of your house, think about how hard it is to mask a 500-gallon tank on the side of your house. This client had 2 500-gallon tanks that were actually hooked, though, to a pressure sensing pump. So the downfall with the rain barrel is it's gravity fed. So the water just kind of pees out of it unless you have some sort of a pump in it. This was actually connected to a pump that gave her like household water pressure coming off of these barrels. So she had 1,000 gallons, then she would use all that collected water to water the beds around her house. Now, like I said, this is where I get more into these things with below ground tanks. So with the below ground tanks, we have the cement cisterns, we have the below ground plastic cisterns, and there's a modular system. The modular system I'll go into a little bit more, but however, this allows you to capture a whole lot of water. This allows you to keep that water out of the sunlight, where those other tanks that I just showed you could suffer from UV degradation, and the water could get heated up, and the plastic could, you know, pollute the water a little bit as it heats up. These allow the whole thing to be underground. It protects the system. The problem with burying the tanks, in many cases, at least that I've seen, is that if I'm digging and I get 3 feet down and I hit ledge and I need to be 6+ feet down to get this tank in, I can't do anything about it, which is why I'm going to show you this modular system that I sometimes work with. But the beautiful thing of these tanks, the cement tanks and the hard plastic tanks, is that they are all set and ready to be plumbed to whatever it might be. And I, like I said, the majority of installations that I do is putting these things in, collecting the water off the roof and or maybe say a patio, collecting all that water, channeling it into a tank, and then either hooking it up to a spigot or an irrigation system. So you're collecting that water. This right here is just an example. This is only one company that does it, but it's a pretty good graphic to show you how these modular systems work. What happens is the water comes down the downspout and into a catch basin. That catch basin has a grid on top that's going to take out any sticks, leaves, or anything of the like. Inside, there's another 200 micron screen that's going to filter out any dust or pollen or any grit that makes it through that grid. So you have relatively clean water making its way to the basin. These modular systems, in this case, and in one of the examples I'll show you, can be hooked up to a decorative water feature. But what happens is these things fill. When they get too full, there's an overflow. So it's a beautiful thing, because if there's too much water and you haven't used that water up, that water then goes to a dry well and essentially just makes its way back into the ground, so that you're not wasting a drop. Then there is a pump within this cistern that is connected to a spigot and, or like I said, an irrigation system. So the installation process all starts with the hole, a big hole. That hole then gets lined with an EPDM liner, similar to roofing rubber or a pond liner. Was that a question? No. And then we installed, you can see, a pump vault, and then it gets lined with geotextile, and then we put the pump vault in it. After that, it gets filled with these blocks. These blocks go by many names. They're carried by many companies. Essentially what they are is they're H20 plus rated plastic blocks that provide the void space for the water. So you can calculate, each one of these holds about 27 gallons. So I can calculate if I'm building like a 1,000-gallon system, a 2,000-gallon system, or a greater, I can essentially know and size that system per the storage that I'm putting in there. In this case, the client wanted to collect from 3 downspouts. They wanted a 1,000-gallon system, but they also wanted to add a water feature to help drown out traffic noise, because water is the best way to drown out traffic noise. And they also wanted to attract more wildlife to their backyard. The best way to attract birds and the like to your backyard is to have the sound of running water. So we put in this 1,000-gallon system, as you can see, built all that up, then covered all that up and built this fountain on top of it. Then they went through and they planted it all up. We came back, and now here it is. It's collecting off of 3 downspouts. The birds come to the top and they catch all that splashing water and they bathe in that. And down below is for the pollinators, the bees and the butterflies butterflies and everybody love the wet rocks. So what's happening here is the water's going over the urn, making its way into those stones, and then going right back into the basin. Underneath that flat rock in the back, right here, is where that lid is. So we just put a rock on top of that lid. That lid holds the pump, and that is a pressure sensing pump. So when they actually have theirs connected to soaker hoses, very, very simple. So we installed a spigot for them. On that spigot, they put like a simple Home Depot timer and some soaker hoses. They wanted to have this 1,000-gallon because they kept going into mandatory water restrictions in their town. And they had a whole lot of new plantings, and they wanted to make sure that they had extra water to make sure that their landscape made it through. So the way a pressure sensing pump works is when the valve opens, whether it be a spigot, irrigation system, when the valve opens, it senses the drop in pressure and begins to draw water from the basin. And then when that valve closes, the line gets charged, the water gets pushed in, it senses that there's pressure in the line, and the pump shuts itself off. Real simple. What I love about these systems is that the only thing that can really break is the pump. There's nothing else. Once installed, there's nothing else that can go wrong with them. Here's another system. This is the first lead home in Dorchester. We built, it's the first lead home in Boston, I'm sorry. It is in Dorchester. We built a 1,200-gallon cistern, same thing, right there under that fountain. This is a lead landscape, so we built 100% native landscape, and we have 2 years to establish that landscape. So we hooked up an irrigation system to it to draw off of this 1,000 gallons. Because we were designing from the beginning, we had both downspouts and in the front of the house so that we could easily capture them and direct them to this system. We only actually ever had to use, because of the landscape and the like I said, I talked so much about soil and plant choice. Because of the plant choices and because of the soil amendments, they actually only use their irrigation system for a year. So they really have a 1,000-gallon basin that gets to just feed this fountain, which the kids who walk by play in, and oftentimes I have a very, very cool video of all these birds kind of just coming to it and bathing in it. This right here is a system down on the Cape. What's cool about this system is the outdoor shower. This client wanted to, lives in Boston, has a summer house on the Cape, and wanted to be able to, did not want all of her gardens and her lawn dying while she was up in Boston. So we plumbed this whole thing to her irrigation system. It's 3,000 gallons. But what we did was we also connected her outdoor shower. So even if it hasn't rained, say over the week, everybody, grandkids, everybody's in the outdoor shower on the weekends. So there was a constant flow of water going to this system, which then, like I said, once this grew in, you could barely even see the green top. But that green top right there is the covering for the pump vault. This right here is Somerville, Massachusetts. So this is a highly urban area. These people had about 15 rain barrels under their deck. It was one of the sexiest systems I've ever seen set up. They were just connected all perfectly, like perfect engineer setup. It was gorgeous. I could have never done anything like it, but they needed more water. So we put in a 2,500-gallon system. They have a very small urban lot. And they also wanted to put in an open cell driveway or a semi-pervious driveway. So what we did, here are the blocks. We installed these blocks, ran all of their gutters to it, and then built an open cell driveway. This is not a permeable driveway because we use sand, but it is a semi-pervious driveway, open cell driveway. You can see the cover right there in the back next to that pot. That's the access to the pump house. We planted it up with clover, viola, chamomile, and thyme. So when you walk to your car, it smells like an herb garden. They also, you can tell that they're very nature friendly. So between the chamomile, the viola, and the clover, you actually have a constant kind of bloom time for the local pollinators.
Trevor, can I
time
ask a
also
question?
blooms. Go ahead, yeah.
So I think that I just like missed the few words where you described this, but the capture system that's below the driveway is connected to downspouts.
Mhm.
And you said that the driveway itself is semi-permeable because you used the sand. So is there any water? What's on top of the cistern system below? Is there any water coming from the driveway into the cistern system, or is it only
Not in this system. You can, let me go back a couple. You can, so here we ended up covering all that whole system,
Uh-huh.
and then covered that system with gravel and then added all the sand.
Okay, right.
And you can see there's the pump vault. So it is relatively permeable, but it is not an official permeable installation because we use the sand. We used the sand because they wanted more than a permeable driveway. They wanted to essentially drive into a garden. So
Right.
that was the idea behind all that. So we seeded all of this. The clover is the workhorse. The clover, you can drive on it, it bounces back. You can park over it for a couple days, it bounces back. The flowers themselves and the thyme all grow in the unused parts of the driveway. They come up in the sunny spots on the driveway.
Can I ask, just like ballpark, what is the installation of a huge system like that? How much would that like run a residence?
It's about $5 a gallon. So the 1,000-gallon system is about $5,000,
Okay.
roughly.
Mhm.
Roughly. You know, this right here, this system was about, this is, like I said, it's like 2,500, it's like a 2,500 gallon system. Ran them about, I want to say 14K maybe. And then we did the driveway, but the driveway was extra. So like some of that, it would have been more depending on what we put on top of it, but some because we were topping it with the driveway. So, you know, you'd be looking at, you know, around 5 gallons. That's kind of the estimating, I would say price. It all depends on, you know, location and what you're connecting it to. So again, like this one is absolutely, it's just connected to a spigot. It's connected to a spigot in the backyard about 50 feet away from the driveway itself. And then they have a whole like intricate hose system running to all of their beds. I do not ever suggest or advocate for connecting any of these to vegetable beds. You know, you don't want to connect, you don't want to connect any of this to anything, any kind of vegetables or produce, because you don't necessarily know what's coming off your roof. You don't know the condition of your shingles. So unless you have a enamel metal roof or a slate roof, I never would say you want to use any of this water for a vegetable bed. However, for perennials, for lawn and the like, this is absolutely perfect.
Can you go back to that? What if you are, and I'm thinking for a vegetable bed, that you infiltrate it into the ground and then it actually pulls from the bottom up to your vegetable bed? What's your thoughts on that? Because then it's actually filter everything out.
So if I created a system like say like a bioswale or something,
Yeah.
that the downspout. So if I made a rain garden or a biocell that the downspouts emptied into, that then had an underdrain that fed the cistern, yep, I would.
Because we have a bunch of vegetable gardens that are fed with various drainage. It goes through the rain gardens, and then there's spots where there are vegetables, but it's already kind of been filtered and it pulls from the bottom up as opposed to watering the surface of the vegetables.
Yeah, you just
Okay.
want to make sure, because you know, heavy metals on especially an asphalt roof, or depending what your roof is, you can get heavy metals, you can get, you know, different pollutants from, you know, from the shingles. So you just want to make sure, especially if you're growing leafy greens. This is so funny to be having this conversation with you guys. So especially if you're growing like leafy greens, they will take all of that directly up into the leaves in which case you will be eating those pollutants directly. Anything that's fruiting, you don't have to worry about so much. So peppers, tomatoes, and the like, you don't have to worry as much. I did a whole study with Wellesley College. We actually did a whole study on this and trying to figure out what you could irrigate with stormwater and what ended up in the vegetation itself. And fruiting things don't, the pollutants don't necessarily make it into the fruit, though they might be stored in the plant. But something like mustard greens or lettuces and the like, they take all of that up directly, in which case you are then eating all those pollutants.
Trevor, did you publish that?
That study?
Yeah.
No, that was just done with a class over at Wellesley.
All right.
There is, Heather, there is literature though that says, you know, to the same effect. I looked into that a few years ago when I was working on a community garden.
I collect that literature. It's something that I have a lot of it. And so I just like to read whatever I find a thing I hadn't heard of yet.
So I can send an email to Well. It was a, hey, let's have this guy come in and do a fun experiment with them type thing. So it wasn't anybody's like official study. It was kind of like an extracurricular thing, but I don't necessarily know nor remember if anybody actually wrote it up in any sort of an official manner.
It's okay. Sometimes it happens, but it's fine. I understand how class projects go and what the output of them looks like. It's the learning is what's important more than the data.
Yeah, it was, I mean, this was a number of years ago, but it was just, the idea was to get people to think differently. I've been doing this for a long time. So I've been trying to get people to think differently for a long time. So
Trevor,
go ahead.
Sorry, because I don't think you're going to come back to it. You had said something a little while ago about gray water systems. You were mentioning for like, you know, plumbing and things like that. And in your experience, I don't know if you've had very many people hire you to like look into that, but is that something that is regulated community by community? Or is it state?
The way I understand it's community by community, because I believe there's a brand new Harvard building that is using all gray water, but there's just a lot of red tape around it. But there's a brand new Harvard building that's using all gray water for their toilets and the like. And I mean, that was designed from the beginning. A lot of communities, what I've found on because I do a lot of this stuff on a residential scale. So on a residential scale, a lot of people come to me. I don't want to call them preppers, but let's just say a lot of preppers contact me and they want to, get off grid. You can do this, I guess, if you're getting all the way off grid, but for as long as you are connected to municipal water, you are usually getting charged for water coming in and water going out. So once you do this, now you disrupt the money flow and nobody likes you to mess with their money. So I don't know about your communities, maybe you allow this, but that's the kind of the gist of the pushback that I've received. And or you can absolutely do it, but there's just such a process that it's just not worth it. And nobody wants to pay, nobody who wants a 3,000 gallon system wants to pay me the months of time that it's going to take for me to kind of push that through to get it plumbed to their house. So.
Okay.
So just to give an example from our region, Putnam Vocational Technical School in Springfield, they have what you call a purple pipe system that captures flow from the roof and is used internally for toilet flushing and then some irrigation in the landscape. So it does happen. Yeah.
That's also true for the Kern Center at Hampshire College. It's still pretty new and they were definitely still working out some kinks, but yeah, they're watering their features outside. There's stormwater features outside, and then they also use it for the toilets inside.
Yeah, there's several living buildings I think there's 3 living building certified in our region. And I do know that that's a component of that program, but it's something that I feel like I never hear about on a residential scale. And that is probably to Trevor's point where it's just so unusual that it takes so much to push it through. Yeah.
Yeah.
And a lot of that deals, I mean, on our campus, we have, we use the gray water from rainwater, but we also do reclaim water, which is from the sewer, which is even more permitting. And all of that needs to go through your local plumbing inspectors, which they, depending on who you get, will yay or nay on what you can and cannot do. And their most concern is about backflow preventers to make sure that there's no interconnections with, you know, your incoming water. But be careful with like the purple piping. I mean, some of it, you got to keep the rainwater versus, like I said, with our reclaimed water, and they're very specific on labeling and I mean, all of our stuff is public. So in every single one of your toilets, you have to have signage and all that kind of stuff. I'm not sure about residential, but when you get into buildings, the plumbing inspectors where you're going to have your yays and nays.
That's the easiest place and the best place to get it going, though, just like with the Harvard building. It's just like when you're doing it from the beginning and you're doing all that permitting from the beginning. And again, if you get everybody on board from the beginning, then it works. It's a lot more complicated as I've seen it. And I'm just waiting to find a loophole or a method of approach that can make it happen a little quicker. But it's different, you know, when there's just a residence in the area, like those people in Somerville, you know, to try to push that through Somerville would have just been really hard. I've tried to do it in Newton, and Newton is pretty, you know, they like their green infrastructure, but it's just, it wasn't going to happen. However, just like in my infinite shower example that I believe I gave you guys, it's just like, wouldn't it be great if then like our shower water, you know, sewer water can be sewer water. I'm not trying to get into reusing the toilet water just yet, but like all of our shower water, all of our gray water, if that were to go to cisterns and then be used for irrigation, that would take huge pressure off, you know, all of our, you know, our water usage, say during the summer, etc. I mean, because it jumps exponentially. So you could be using all of that water to water our landscapes. And if you put that on a campus level and say the ball fields and everything is irrigated from all the shower water or the like, you know, that would just be great. Of course, there's things that you have to worry about. The backflow preventers I hear all the time, and that's easy. That's just an easy install. You have to install a backflow preventer when you install an irrigation system. Like that's not hard. It would be just like, it would be making sure, like, let's just say we're on the UMass campus and we're using all that shower water to do all the green space. You know, you just need some sort of, you probably need like a UV filtration or something to make sure that you're, you know, killing some of that. But you know, I think that's a great use of water, and I don't think it would be too hard. And I know it has been done before, you know, as far as like cleaning water is concerned, it wouldn't be too hard to take all that water and to actually use it. And, you know, it's that thinking and that motivation to do it. It's easier to do with new construction, of course. But this one use water, using water like we use Kleenex is, you know, I think we're going to have to start coming down to the end of, at least maybe not in our area, because we seem to be getting, and it looks like on the climate modeling that we're going to continue to get more and more water. But, you know, for areas that are going to start drying out as we get more water, you know, you may want to, you know, we may have to start thinking like that. Any other questions about rain harvesting before I go to permeable pavements, which we just did, but we'll do again? All right. So permeable pavements, we have permeable pavers, and I will show you a walkthrough of an example. This is in Medford, which is my client's house and another house, and there's a teeny tiny driveway in the middle. Now, the neighbor's house, which you are looking at, has 2 downspouts that spilled into this driveway, and my client had 2 downspouts that spilled into this driveway. These are triple deckers, so we were dumping 1,000+ gallons in between the 2 houses. Now you can tell by the bricks on the foundation that these houses were built in the 20s and 50s. So the foundation themselves are relatively compromised, and my client was getting water in the basement. So what they tried to do was they took up their broken asphalt driveway and they said, oh, we'll just have grass and gravel. Well, that doesn't work because grass and gravel, when you drive over it when it's wet, compacts the soil. So they essentially ended up with an impervious area again and getting more water in their basement. So we did this massive excavation and built a permeable system between their house, excavating down to 20 inches. We installed the gravel, compacting it in 4-inch lifts. Now we install these pavers. Again, what makes the pavers permeable are the exaggerated joints in between. So you can see that we have the 3/8 crushed stone as the bedding layer. What you're looking at is the number 9 stone that we talked about. Now you're going to use number 8 stone for the test, but for this we have the number 9 stone, which essentially is like stone dust minus the fines, like I said. So there's kind of just the before and after. My client's house is on the right. We did not waterproof their basement or do anything else. We simply eliminated the water that was going in their basement by giving the water a better place to go. You know, the water would dump onto the driveway. It's instantly going to drop that 20 inches and then have plenty of room to spread out and begin to infiltrate into the native soils. Essentially, we created a 6,000 gallon water storage system between these two houses. So when Boston goes under, you can hang out on this driveway and you'll be high and dry and just fine. This is a project we did, we worked on with the contractors for the Beardsley Zoo. So Beardsley Zoo has a lot of wonderful stormwater examples. They have a big rain garden in their parking lot, but what they were doing was sections of their parking lot. It was going to be too much to do the entire parking lot. So what they did was they divided the parking lot really into thirds, and they created these strips, these permeable strips to infiltrate the water as it comes down. So this strip right here infiltrates all the water coming from the ticketing area and kind of this upper parking lot, and then you go down a ways and there's a strip that goes across to collect that water. So we're breaking it up into pieces. So not to spend the millions and millions of dollars to do the entire parking lot, we cut that budget way down, and we're able to achieve much of the same infiltration and water infiltration and water interception as if the entire parking lot was permeable. So here you can see we had the fabric down the sides, compacting in lifts. This is just to show you there's the 3/4 gravel with the 3/8 on top, getting ready, setting up that bedding layer. We did a big education day. So I was teaching people about it, which is the big thing that I try to incorporate. Anytime there's a grant involved or anytime there's something like that, I tried to build an education day or some sort of a education part into it so that we can kind of expand the use of these products. So there you can see there the pavers laid down. These have a much smaller joint, but they still are permeable pavers. The other one was extremely exaggerated because we were trying to capture a lot more water. But there it is, all sitting on the 3/8 gravel, filled with the number 9 stone. Just an example of a permeable driveway at the bottom of a slope. And then here's just another one. This is just a really long, long residential, both these are residential scale, but long permeable driveways. This client too was getting water in the basement. They had nothing but a cracked asphalt driveway. They were going to replace it anyway, and they wanted to try to get more water away from the house. So we installed all of this. So after pavers, we get to pervious concrete. Like I said, my experience mostly with pervious concrete is like this. It is installing large pads that can get cut to any size and I guess any shape that you want. You just drop them into place. These are set up almost like the permeable pavers. You don't necessarily need a choker course, so this can go on to 3/4 gravel, no choker course. These were installed over a 3/4. This is not my installation, but this is a great example of using these when we're talking about street trees and creating pervious areas so we can have the water feed the street trees and we can increase the soil volume and for the, for the root mass around the street trees. So this is a great use of, because otherwise in this little teeny tiny median strip, how much water is really going to land there to support a full-size tree? Maybe something like this, but if this was impervious concrete, then all the water would just run off and very little would run into that 3x3 square.
Does that have that box underneath it, do you think, for the roots? Can
I
you do
don't-
that?
I don't know, but yes, you could do that. You absolutely could do that, but I don't know the full extent of this situation. I included the example just because it's a great use of those large pervious concrete pavers. But if this was my installation, that's exactly what I would do, because you're going to excavate all this anyway. You're putting in the street trees anyway, so I would create all of that soil volume underneath, and then just create that compacted stone layer and then put this on top. So those roots could just go out everywhere. My problem with this image right now is that those trees are planted too deep. It's just the number of trees that I see planted improperly, just it drives me crazy. So this is the alternative. This is the asphalt alternative that I was describing earlier. This is porous pave. I have installed miles of it in this area. We are the largest installer in the Northeast. That's just a thing. This is much larger product down in, say, Pennsylvania. Essentially, it's 50 pounds of rubber chips, 50 pounds of 3/8 gravel, and 5 quarts of a urethane binder. Those rubber chips are made from recycled truck tires. There is numerous. I had a lot of pushback when people tried to sell me this product, but there are numerous third-party studies that say that there isn't any heavy metal leaching involved. So unless those studies are false, I believe in the quality of this product. My beef with this product is that, yes, it takes tires out of a landfill, but it takes tires out of a landfill like that fleece jacket takes bottles out of a landfill. There is nothing right now designed to do with this. So if this walkway that you're looking at right now is ever to be taken up, there's no way to recycle it. It's ultimately going to go to the landfill, which ultimately means you just kept the tires out of the landfill temporarily. Just like the bottles for the recycled the jackets and stuff, the recycled bottles on that, those bottles are out of a landfill for as long as you're wearing that jacket. The moment that jacket goes in the trash, then all those bottles go in the trash. So it's that next level of recycling that I would like to see. On a small scale, this whole thing can be done in a wheelbarrow, as you can see with this project that you saw before. This client had that downspout spilling out over their driveway, which was creating a huge sheet of ice over 3/4 of their driveway. So what we did was we cut a gutter down the side of the driveway, dug a trench about 16 inches deep, filled it with 3/4 gravel, and topped it with this asphalt alternative. So when they are not using their rain barrel on the right, the downspout is just dumping into that gutter, and then that water is just filtering as it runs down the through that trench. They did not have the money to do the entire driveway. So the reason I put this in here is because this is a stormwater solution that did not require pulling the whole world apart. We were able to just handle the water from the source and make it go away. On a larger scale, this is done in Wellesley. We did a 1/2 mile walking path along the Charles River in Wellesley. We did it for John Hancock, but it's actually on public land. So the whole thing, this gets screeded out just like concrete. It gets screeded, it gets troweled out just like concrete. Like I said, it's a 1/2 mile walking path through the area. Whoops, okay, that's a slide out of place. I'm glad that I did this with you guys. Here is a pervious pavement, just like that. In the winter, this was just shoveled, and you can see the footprints through it, but this is just the 10 o'clock sun. This is down on Cape Cod at the Association to Preserve Cape Cod. We did their handicap parking and their walking path. And this was just hit with a snow blower. They hit it with a snow blower and a shovel, nothing else. The sun hits it, boom, it's clear. So that answers some of the questions about winter and what it looks like. This is a green roof project we did in the Bronx. We created permeable walkways throughout the green roof and built this park up on the roof. One of the best applications of this asphalt alternative are tree pits, because your standard iron or steel tree pit, great, will eventually bite into the tree, which will kill the tree. It also has all those wide openings, so anybody with, say, heels or whatever will go right through that. So this makes it easy for anybody to walk on. It also keeps all of the fines, all the dust, all the everything out, because in those tree grates you get trash under there. You get all the whatever's washed off the sidewalk into there. Oftentimes this is in Boston, so what they're doing is they're using pressure washers on the sidewalk, so they're just pushing all of that water into the tree pits, which essentially ends up clogging and compacting the soil, because all that water is just getting pushed into there. So it ends up compacting the soil and killing the tree. So this is a way to kind of protect from that. Now, granted, if you cannot push all that silt and everything into these tree pits, you have to kind of change the way you do your maintenance. One of the biggest ways that this is being used now is in golf courses. So this is the Winged Foot Golf Club down in Connecticut. That right there is a very dedicated Winged Foot employee learning how to trowel porous pave. But what we did was they had gravel pathways and stone dust pathways. The gravel pathways get all over the place, so they wanted to eliminate that maintenance. And the stone dust pathways got worn down and would, get divots in them and collect water. So by putting this down, we increase the permeability of the area, we decrease the maintenance, and it does fine. Downfall to this, we found that where the carts turn off the path, there's a lot of wearing. So once you wear down this surface, this is the surface that I was talking about that needs to be resurfaced, which just means it needs binder sprayed over it like every 3 years. And where there's a lot of wearing, like in a driveway, which we've done these in, and in an area like this, you definitely increase the maintenance. Where it was a walking path, not so much. So this is the walking path project, the Wellesley Office Park. You absolutely can go here. If you are ever driving Route 9 westbound, pull off into the Wellesley Office Park, pull off to the side, and you will see those stone pillars and you can enjoy the walking path. It is about 5 years old now, recently resurfaced last season or the season before, because it started to kind of fleck. The idea behind this walking path was not to prevent stormwater runoff, because it's in the middle of the woods. The idea here was, because it's built along the Charles River, was to allow the water to come up through it. We wanted to build this walking path without interrupting the hydraulic flow, of the area. So when the water swells and when the river swells in spring, the water comes right up through this path. And then when it recedes, it goes back down. But the whole path is a big monolithic piece. It's a half-mile monolithic piece. So it rises and falls together. It's not like it breaks apart. So the maintenance on this, they have somebody go through and blow it off in the morning. And they haven't vacked it out like they should, but it still seems to maintain. They have resurfaced it. They will need to continue to resurface it. I was a little hesitant at first about putting 600 tires along the Charles River on this walking path, but this is visited by over 200 people a day. It backs up to the office park, so everybody in the office park uses it, but it is ADA compliant walkway. And the idea of allowing all those people to enjoy the seasons and enjoy the Charles, and make it's 7 feet wide, so it's an easily accessible, easily walkable path. And my whole job is to educate and connect people to nature. So it seemed like a great opportunity. What we did in creating this path was we chose the path through the woods based on sick trees, invasive trees, and very young, unestablished trees. So that's how we kind of made our way through the woods. And so the path is very windy. And then what we did was, before excavation, we root pruned the sides of the pathway so that when we went through with an excavator, we did not dig up and tear out the root systems of all these trees, further killing all the trees along the path. So it was very well thought out and very well executed. The paving part itself took 10 days. So it was a half mile or 10 days of just screeding and spreading like you saw in that picture, throughout the woods. And like I said, I'm very happy with the amount of use that this project sees, and the way that it does actually connect people to the seasons. Grid systems, as we talked about, another thing that I install often. There's a number of different, this is HexPave. There's a number of different systems out there. This installation we actually did at, we took a vacant lot and turned it into a community garden. And there's a portion of the community garden that we wanted to make very stable, not necessarily ADA compliant, though you could go over it with, say, like a wheelchair. But we wanted to make a sturdy area for the elderly citizens of the neighborhood so that they could access a number of the beds. So there's a bunch of beds set aside for elderly and otherwise, not necessarily handicapped people, but accessibly challenged people. So we created this stable area using the grid system and just blew a bunch of mulch into it. This right here is the drivable grass, the other product that I talked to you about. This is a cement system. And this right here is, we're installing a secondary driveway on a client's property so that they can get to the back end of their property. So their driveway is up there at the top, and this is just a driveway to make it down to the end of the property. These grids go down in big squares, like I said, with all those little squares attached, like it's big tile. Put it down, cut the sides out, and we filled it with a sandy loam, and then seeded it again with that clover mix. So it's going to have meadows on either side and the clover mix down the middle, so that it doesn't necessarily need to be mown, and you can just drive up and down it as needed. And this is just from the Drivable Grass website, so you can see what it looks like grown in. That's one of my favorite products. It's very versatile. It's very durable, and extremely easy to install. And like I said, I like it better than the plastic because I'm not a huge fan. I feel like everything I do via stormwater is installing plastic in the environment. So for maintenance, as we talked about, when you are installing the porous pave or the asphalt alternative, you will need to vac it out, and you will also need to either spray or roll on a coat of the binder to just reinforce the integrity of the surface, especially if it is a driveway or a place where vehicles drive over it. For the pervious concrete, you will need to use the vac. That Billy Goat vac is the kind of vac that I use on pretty much every installation that I do. And then for the pavers, like I said, you will need to replace that joint stone. I recommend every 3 years. And what you do is you just go over with the vac, you suck out all the old joint stone, and you put in all new joint stone. And that is currently how I maintain all the installations that I have in. Does anybody have any paver questions before we move on to rain gardens?
What is the binder?
What is it made of?
Yeah.
I do not know the chemical makeup of it necessarily. I know it is a non-toxic urethane binder.
So, okay, and that's just like a commonly known product. It's not different because it's for the porous or for the alternative porous pavement or whatever. It's the same binder.
The same binder as what?
I don't know. Do you use binders?
The binder, that binder is designed for the porous pave.
Ah, okay, great, thanks.
So yes, it is a binder designed for the porous pave. When you put it down, like I said, the porous pave goes down like cement. So you dump it out of a mortar mixer and you screed it out, you trowel it out smooth, and then because I've had to remove sections of it, what happens is all that binder kind of makes its way down and locks itself into the subsurface. It looks like honey. It's like pouring honey into the mixer, mixes it up, and it goes down and it kind of locks the whole system together. That system is great because when you patch it, and one of the things I like about that product is when you patch it, the patch just becomes a part of the system again. It's not like an asphalt patch that kind of sits on top. It's like that those patches just become part of the whole system. So for instance, we just had to, 2 years ago, we had to replace a section of that pathway because a tree came down. So the tree came down and undermined, like the roots, as the roots came up, it undermined the whole path. The path itself actually didn't rip or tear or any, like it didn't break at all. It just fell down into the ditch left by the tree roots. So we ended up having to cut that out and re-pour it. But it was pretty impressive that the whole tree just kind of went over, a big 40-foot tree went over, all the roots kind of tore the whole system out, but the path itself didn't break. It just remained a big mat, which was kind of neat. Any other questions about pavements? We've talked a lot about it today. All right, we'll go into rain gardens. We'll touch on rain gardens and bioswales. This we already went over, the definition between a rain garden and bioswale. Rain gardens using native soils does not have an overflow or an underdrain. A bioswale usually has engineered soils, overflow, and an underdrain. The 5 basic rules to planting a rain garden: it must be at least 10 feet from any building. You want it 10 feet from a foundation. Rain gardens and dry wells, you do not want to infiltrate water within 10 feet of a foundation. Must drain in under 24 hours. 36 hours is the cutoff for mosquitoes. It is best that you have your rain garden drain within 24 hours. That is the goal. You never put a rain garden or a bioswale in wet spot on a property. Like I said, this is designed for landscape professionals. And oftentimes people ask landscape professionals to put rain gardens in the wet spot on their property. That is not what rain gardens are for. Rain gardens would be then set upslope from the wet spot to intercept that water and ultimately dry out the wet spot. But a rain garden is not meant to be a planted swamp. It's a water infiltration system. You do not use wetland plants in a rain garden. Oftentimes people mix this up, and we already talked about that, so I won't really go into it, but you do not want to be putting marsh marigold and the like in your rain garden because it will be dry more than it will be wet. And when you are planting a rain garden or a bioswale, you want to consider planting for wildlife as well. So it will be beautiful because any plant you put in there is going to be gorgeous. But it is best when you're designing to choose your plants and also make them wildlife friendly. So if you can plant a host plant for some sort of a pollinator or a butterfly, if you can plant a plant that is going to provide seeds for wildlife in the fall, anything we can do to help out the wildlife that we are stressing so much is definitely a benefit. This is quick and dirty. Landscaper checking drainage if you are in somebody's yard. Digging essentially a shovel depth deep or so, about 10, 12 inches deep, and dig about a square foot, 10 inches deep. Fill that with water, let it drain, fill it with water again. The water's there for 6 hours, it's perfect. 6 to 12, it works. 24, find a new site. You can't have a rain garden. Sizing the rain garden, well, we would use different calculations for anything bigger, but this again is just quick and dirty ways for landscapers to size rain gardens for residential properties. And you are going to take the square footage, divide it by 6, and that is going to give you the square footage of the rain garden you need. Here is that example. If you have a residence, 1,800 square feet, you're going to take a portion of that, divide that in half because it's each going down a downspout. 450 divided by 6 is 75. So we're going to have that rain garden 10 feet from the house, and it will be 75 square feet, and that should be able to handle a 1-inch rain event. Like I said, I design everything for 2 inches plus. So usually a residential rain garden like this, I'm designing for a 2-inch rain event because I don't want to flood anybody's yard. I don't want to flood anybody's basement. Anything on the larger end, I design even deeper or for more water than that. This client had a sloped driveway off of a slope. So they lived on a hill and all the water came down the hill and then down their driveway and pooled in front of their garage. So we gave it an alternative. So we allowed that water to flood off of the driveway and into this 2-bay rain garden. So there's a 4-bay that you're looking at, and then in those boulders in the back, there's actually a second depression. Then they were connected by a 4-inch pipe. So we planted this up with our favorite native perennials, essentially turning it into a pollinator garden, but planted it up with all the natives. So the water comes in right there over that carex, over that grass in the front. So it makes its way through the gravel, comes through that grass, and makes its way into the rain garden. If there is a whole lot of water, like I said, it makes its way into the back portion of the rain garden. We designed this little land bridge to go in between the front portion and the back portion, so the client didn't have to walk all the way around the rain garden to enjoy their side yard. Essentially, once it was all planted, it looks just like every other garden. Like I said, it does not necessarily need to be special. There it is. That could be just a standard perennial garden. But what is it? It's a rain garden. So it's going to collect the water. It's going to handle the stormwater runoff. It's going to provide food for pollinators. It's going to provide host plants for caterpillars that will eventually become pollinators, and will provide seed heads for birds and plenty of beautiful flowers for the client to look at. So the water comes over that pea gravel and through those stones, and then makes its way into that 4-bay right there. This right here is a bioretention cell. This is a photo from Parterre Ecological. This is a bioretention cell in Cambridge in summertime. Beautiful, looks like a garden. There is the bioretention cell in the fall or early winter after cleanup. So that water is coming in from the left. You can see that spillway, the water comes in from the left. It enters the cell. You can see the beehive in the back. For when it gets too full, that's actually set a little low for my liking, but this biocell collects a whole lot of water, but you know, there it is, just full and beautiful, a mix of native and non-native plants, but just a big, beautiful garden. And then it all gets cut back. The vegetation gets removed in the spring. You're gonna have to come through and get all those, you know, get the leaves out of there so you don't have excess nitrogen, so you don't have excess runoff, not runoff, but excess nutrients and clogging of the cell. This area can then get remulched with like a leaf mulch, but it's pretty full. So once it gets going, it doesn't need too much. And you have all those roots and all those different depths. So the echinacea and the grasses have really, really deep roots. And the milkweed there has very shallow roots that just kind of run everywhere, and that kind of spreads. It has lilies on the edges, which eat up which love the sun. They can take the dry hostas in the shade, and of course those birches are loving all that water. This right here is just a bioretention cell that I snapped really quick down in DC a number of years ago. It's got a little sign letting everybody know who walks by what it is, but the water enters up top, makes its way through the cell, and then exits down again at the bottom, if it does ever make it out the other side. But it's all planted up with birches. It's got annuals in there, so they plant it seasonally, while the middle is just planted with perennials. This is that project that I referred to when we did the 5 rain gardens around Boston with Youth Build Boston. We started in the spring rehabbing this rain garden, which was just trashed. This is in East Boston. So we've rehabbed it. We fixed the gravel. We replanted it with new plants because it had been neglected for some time. And then we spent the season recording and maintaining this. So we came through every other week and took out all the trash, made sure that it was working properly, made sure that it wasn't vandalized, made sure that everything was growing. And like I said, we kept a record book. We did 5 of these. So by the end, these guys could identify, the weeds. They could identify all the plants that weren't supposed to be there. We learned about removing them. We learned about silt buildup. We learned about how they were mismanaged in the past. But by the end of the summer, they had a pretty intimate knowledge of each of these 5 rain gardens. Unfortunately, that grant didn't end up going anywhere. And these guys, to my knowledge, never got hired by Parks, which was my hope. Because the idea was that the Parks Department was saying, we don't have enough staff to maintain all these rain gardens and they're going to crap, can you guys take care of them for us and do these records? And I was like, hell yeah. Why not train that staff? And then especially if you can get hired by Parks, because then, as you guys know, you get great benefit packages and everything else. So, this is a wonderful opportunity for a handful of individuals who are looking for an opportunity. Like I said, they didn't end up getting hired that I know of, but this is a program that I will keep throwing at the wall again and again until it sticks. Because I think taking young adults like this, teaching them exactly what's what, to supply the extra staff that you say that you need, is a perfect way and a perfect opportunity for people.
So Trevor, what was that grant program?
It was a grant. I can't remember the name of it. It was an EPA grant that was given to Youth Build Boston, and they partnered, like I said, with Parks to make that happen. And like I said before, it's like anytime I have a grant opportunity, I try to I call it be the plunk. I try to make the biggest splash and cast the ripples as far as possible. So the idea there being that we have an entire summer, 2-3 times a month to go out and learn everything about these different systems, because every rain garden was different. There were some in Boston proper. There were some in East Boston. I mean, they were all in Boston, but some were like close to Chinatown, and some were in Roxbury, and some were in East Boston. So they got to see kind of all these different systems, the pluses and minuses with all those systems. Each one was in a totally different environment. One of them just caught all the trash from the street. It just everything blew in. Ones were just inundated with people's pets, which was not so nice. But they got to, like I said, they got to learn, but they knew the inlets and the outlets, and they could identify the sediment buildup and what to do about it. It was a really great project. Overthinking. This is what happens, I feel, most when handling stormwater. This right here, I have no beef with engineers or anything, but this client right here is in Gloucester. They were getting fined by the town or the city, I don't know what Gloucester is, because their backyard was washing out into the channel every time there was a heavy rain event. They hired a stormwater professional to come and look, and they got a quote for almost $40,000 to handle the stormwater in the back of their property. They then called me for a second opinion, and I handled it for $1,200. We dug a 3x3 hole, 16 inches deep, filled it with 3/4 gravel, put a piece of bluestone on top of that so the water comes down the downspout, it's diffused over the bluestone, falls into the basin. If there is a giant rain event and this gets overwhelmed, then that basin, yes, does overflow, but the water then creeps down the hill, because it's a sloped lawn, down the hill over the grass, and does not, we've now stolen all the momentum and everything else out of it. So much of on a light rain, all that water infiltrates down below, and on a heavy rain, all that water just makes its way away down the grass. So right here is a commercial residence. This guy spent almost $48,000. He spent over $45,000. He had 2 sump pumps installed. He had the basement waterproofed, and then he had a French drain or curtain drain installed in his basement. So they cut out the floor, put in the gravel, had pipes leading all to the sump pump. We're still getting water in the basement. So called me in just to see what was what, and to see if I could figure out why They kept getting water after all of that into the basement. This job I did for free. I want you to take note of the slope of the land. When I got here, that downspout came directly out from the building this way. So the water was coming down the downspout, exiting the downspout, and then running downhill into the window well. So I simply just wrapped the downspout around the corner, problem solved. Like I said, we have to go in when we're analyzing stormwater problems, when we're looking at much of this. You know, you don't necessarily have to be, for some things, especially on scales like this, you don't have to be an engineer and you don't have to take heroic measures. Sometimes you just have to think like water. And you just have to give the water a better alternative. Like in the permeable paver example, by giving that water a giant place to spread out, it stopped trying to go through the crack. Water wants to go somewhere. So if it sits up against a foundation long enough, it's going to go through a crack. If you give it a wider pore space to go through, it's going to go that way. It does not want to squeeze through the tiniest crack. It wants the path of least resistance. So as long as we understand that, think like that, wrap it around the corner and just let it run downhill to the back of the property, problem solved. But water running uphill and then down into the window well, this is what happens when, you know, when you have a hammer, everything's a nail. You know, it's like, this is what happens, is bringing people in to fix the basement, but nobody took the time to see where the water was coming from. The biggest thing is to identify the source of the water. Where's the water coming from? Why is it getting in the basement? Not just, I'm in the basement and I'm going to waterproof the basement, because you don't know where the water was coming from. So like I said, just the example, water going through the window well. Signage, big thing. That top one is the rain garden at the urban rain garden that I was talking about in DC. The sign down below is one that we created for a green roof project that you will see momentarily. This right here is the sign that was created at the Beardsley Zoo for the rain garden that they have in their parking lot. Anytime we have a public installation, if possible, it is great if we build into the budget some sort of signage so that we can educate the public to what's going on. Otherwise, this rain garden right here at the Beardsley Zoo just looks like a beautiful garden in the middle of the parking lot. Nobody understands what it's about. Understanding that it is a functioning system will help people understand stormwater, will help people understand stormwater management, and will help people understand stormwater systems better. This is an app that I suggest that people use for sizing their rain gardens. It's great for smaller projects, nothing on a municipal scale, but it's got nice sliding scales, so I can just do up my the sizes of my rain gardens and stuff real easily. Green roof systems. These we will be seeing in the next day or two when we go through green roofs. These right here are the elements of a green roof system. You have of course, the rubber membrane that is down on the roof. Then on top of that, you have a root barrier, drain mat, optional water retention fleece, the growing medium, and the pre-vegetated mat. We're going to be going through all of this later, so I'll be brief on it, but I will just show you this example. This is a residential example. First thing that happens when anybody calls me for a green roof is I tell them to get a structural engineer. And that structural engineer needs to tell me how much weight I can put on that roof and if that roof can handle a green roof. After that, I tell them to get a roofer to certify that that roof is, that roof membrane is suitable and that the roof itself is waterproof. Once I have 2 people sign off on that, then I know if anything happens to the roof, it's my fault and we don't have a circle of people pointing fingers at each other. So at this point, this is a client who lives in a Frank Lloyd Wright-esque house in the middle of the woods, and they wanted to build a green roof on their garage that resembled the landscape around their home. So once I was signed off on all of that, we put down the green roof. So we put down the root barrier. The root barrier keeps the roots of all the plants from messing with the EPDM liner at all. Because what can happen is underneath the tape, the seam tape that holds the liner together, or little tiny pores in the liner, tiny roots can get in there, exploit that. And when those tiny roots get big roots, then you have an actual hole in your liner. So the root barrier makes sure that there is no way that those roots are actually going to molest that liner whatsoever. It is also the time of the project that I can relax, because once the root barrier is down, I am not worried about anybody's big ass feet punching a hole in the liner. Next comes the drain mat. So the drain mat, in this case, some of them look like egg crates. In this case, it is a piece of recycled polyester fabric that has dimpled plastic on the other side. So that dimpled plastic creates a vapor barrier or a drainage area, so the water can make its way through. It hits the root barrier and then can just run out to the roof drain per design. This water retention fleece is, it adds a sponge layer. It adds a 1-inch sponge layer on top of that drain mat. So the drain mat, if you're designing real lightweight and real quick draining, that's perfect. If you want to retain more water, either for water retention reasons or for ecological reasons for the plant material, for instance, in this case, this roof baked in the sun so much and we were not able to get the soil depth that we wanted. So by adding this, we added more water retention so that the roots would have a little extra water to draw from. Then on top of that, you put the media. This was designed with low bush blueberry and bearberry, which was what was growing on the hillside around them in the woods. They had lots of little low bush blueberry and the like, so we planted their roof up. We used a special soil media that we created a special soil media to handle these ericaceous plants. Otherwise, a normal green roof media is usually expanded shale, pumice, or the like. It's very aggregate based and quick draining. This was very quick draining, but this was made up with core fiber, biochar, pumice, and then we had some humates in there to help kind of add some organic matter, and then we had a little bit of compost in there and planted it up like that. So the nutrient load off of this wasn't very high, but there was enough organic matter to allow the roots and allow the soil microbes to get established, but it also enough so not to get too heavy. And then again, that water retention fleece was there, so as this soil drained out or dried out, capillary action would draw that water up and these roots would remain moist. The Philadelphia bus shelter. This is another project that we did with Youth Build Boston. We had 15 roofs around around the city, mostly in Dorchester, Roxbury, and Mattapan. And what we did was we built green roofs on bus shelters. We built green roofs on bus shelters to prove to the city and to prove a number of things. We wanted to prove that you could install green infrastructure, much needed green infrastructure, for short money. These were going in 2016 at about $5,000 a piece, and that paid everybody a living wage. So that was materials and a living wage. They went in at $5,000 a piece. The idea was that we would train this crew to install and maintain a green roof for the course of the season. Once that was done, if the program got picked up, then the city or the T, whomever was dealing with it, would have trained staff who knew how to install and maintain these things, and we could install more and more every year. If not, they could then go on, because the hardest part about being a young person is they say, what's your experience? And you say, I don't have any because nobody's hired me yet. So then they could go on to a group like Recover Green Roofs or Apex Green Roofs and say, I do have some green roof installation experience. Because if you can put a green roof on 60 to 80 square feet of a bus shelter, ultimately you could do 10,000 square feet. It's different when you're 7 stories up, but essentially the mechanics are all the same. So again, the other piece to this was that if we had put green roofs on all the shelters in the Boston area, we would have achieved just about an acre, which would have offset 27,000 gallons in a 1-inch rain event from going into the storm drains in Boston, giving some relief to the storm drains and hopefully offsetting some of the flooding. So the idea behind this was to show that lots of little pieces can add up. It was also to show that you don't have to spend tens of millions of dollars every single time to install green infrastructure and to make this whole thing work. So like I said, we had them in Upham's Corner and throughout Boston. We planted them with sedum, with 4 inches of mix. They were about 7 pounds per square foot, 8 pounds maybe saturated. We then seeded them with drought tolerant native perennial seed. The idea was that if these were allowed to grow, they'd just be big, colorful pieces. The final portion of this was to bring the conversation down to street level, which absolutely happened because we were adding green space and beautifying, you know, the roadways in these areas. People were asking what was up, and I showed you that sign. You know, each bus shelter had a sign in it describing that we were drawing down carbon, we were offsetting stormwater, we were creating jobs, we were cleaning air, you know, the whole function of it. Again, all about the education and all about educating the public. This right here is just, I went out in a rainstorm and I held a water bottle under the gutter of a bus shelter that did not have a green roof and one of our green roofs. And just to show the difference in the water and the runoff that was coming off of those. And then trees, as we talked about, trees are the cheapest, easiest, and one of the most effective methods of green infrastructure. They draw down carbon, they provide habitat, they clean the air, they add moisture and cool the air and cool our environments via shade and just via evapotranspiration. 25% of atmospheric carbon is captured by trees, but those trees need to look more like this and less like the little twigs that we initially put in for them to be most effective. So the idea is to get trees big and very effective. And GICP, you're in it, you don't need to hear about it. But there is me. If you haven't checked out the Re-Earth Instagram, if you're an Instagram person, you can see more of the stuff I do. And that ends that right there. The only slide that I noticed that was missing was I have a shot of the records that were kept of the bus shelters. And you can see that the bus shelter, the green roof itself is 81 degrees and the sidewalk is like 137 degrees. So I have to thank you for doing that with me, because now I realize I have to throw that slide in there. But we had the team, as they were managing, they had a thermal gun and they shot the sidewalk and shot the roof. They kind of recorded what the vegetation looked like. And then again, was there any trash on the roof? Was there any vandalism? What did things look like? Did they see any pollinators or any wildlife on the roof? What was happening? So it was a pretty good example. None of those bus shelters exist. Boston, as you probably know, works with JC which is a third-party bus shelter company, and JC wanted nothing to do with that program. The T, who owns the other portion of the bus shelters, loved the idea and wanted us to put up more as long as they did not have to pay to maintain them, and they gave us 48 hours to take